Introduction. This unit introduces the term database, its types, and its advantages. It also focuses on basic structure and elements of database. At the end, it provides solid concept of entities. Objectives. The objectives of the unit are to explain importance of database course, database concept, various architectures of database, the cost, risk, and environment of database management system, difference between data and information, the concept of entity and attributes, various types of attributes, how entities are recognized in an entity type, how various entity types are associated with one another. Database introduction. Every organization in the real world is like a system, which requires resources in order to fulfill its main objective. These resources are: Number 1, physical resources such as human resource, equipments, etc. Number 2, logical resources such as data. It is very difficult to rely on physical resources. For example, if it is required to check the course registration of a particular student, it is unusual to call a student for verification. Similarly, if it is required to check the balance of a particular item in the stock, it is again unusual to start counting the items available in the stock and then subtract from the total figure. Therefore, we can say that dealing with huge amount of physical resources, we must rely on the logical resources, that is data. So it becomes easy for us to check the record of student registration and similarly check the data of item in the stock. Therefore, in today's modern era of information technology, data is considered to be one of the most important resource and asset of an organization. If an organization fails to recognize the data, it will not be able to work properly and efficiently. Realizing the fact, database management system has emerged as one of the most important courses in the information system curriculum today. Therefore, most of the business organizations keep their data in an organized shape in databases. Now let us define the term database. It is an integrated collection of data shared by many legal users. To understand what is database, we need to understand integration, sharing, security. Integration. Every system in the real world is found in the integrated form, such as a faculty in university is the integration of many related departments. Each one is easy to administer and manage. The database is also like a system, which is not simply a large collection of data in a single reservoir, but rather the integration of many organized units. Sharing. The data in database is stored at one place and is used by a number of users. So it is a shared resource among number of users. Security. Unauthorized user cannot access the data stored in the database. Types of databases. The databases are classified broadly into two groups. These are: Number 1, according to architecture. Number 2, according to functional units. Let us discuss each one in more detail. According to first classification, there are further subtypes of databases. Personal computer database. This type of database is developed on personal computers. For example, consider a company that has a number of salespersons. Each has many customers. Each salesperson might carry a laptop computer with a simple database application to record customer information and the details of contacts with every customer. Let us now discuss some important characteristics of personal computer databases. These are: Number 1, it satisfies the need of only one user at any given instant of time. Number 2, it is implemented on stand-alone personal computers. Number 3, it is simple to design and develop. Number 4, it is widely used. Number 5, it is low cost. Central computer database. This type of database is developed on mainframe or mini-frame computers. Let us now discuss some important characteristics of central computer database. These are: Number 1, it satisfies the needs of many users at any given instant of time. Number 2, it is implemented on mainframe or mini-frame computers. Number 3, it has complex design and development. Number 4, it is costly than personal computer database. Number 5, covers medium scale as well as large scale organization. Today, most of the organizations are moving away from central computer databases as the environment of mainframe or mini-frame computers is very costly in terms of initial investment and maintenance. Client-server database. This type of database is developed on client-server architecture, that is local area network. Let us now discuss some important characteristics of client-server database. These are: number 1, it satisfies the needs of many users at any given instant of time. Number 2, it is implemented on client-server architecture. Number 3, it is costly than personal computer database but cheaper than central computer database. Number 4, it covers medium-scale as well as large-scale organizations. Most of the organizations are opting client-server databases as the client-server environment is affordable and efficient. Distributed database. This type of database is developed on wide area network and suitable for those organizations which are operational in widely spread geographical locations. Let us now discuss some important characteristics of distributed database. These are: number 1, it satisfies the needs of many users at any given instant of time. Number 2, it is implemented on wide area network. Number 3, the design and development is complex. Number 4, it is costly than client-server databases as communication channels are involved. Number 5, it covers medium-scale as well as large-scale organizations. Now let us discuss the second classification, that is according to functional units. There are further subtypes of databases. These are personal computer databases. The personal computer databases also fall in this category without any change as discussed in first classification. Workgroup databases. A workgroup is a relatively small team of people who collaborate on the same project or application or on a group of similar projects or applications. A workgroup typically comprises fewer than 25 persons. Each member of the workgroup has a desktop computer and the computers are linked by means of a local area network. The database is stored on a central device called the database server, which is also connected to the network. Department databases. A department is a functional unit within an organization. Typical examples are human resource, marketing, manufacturing, and finance. A department is generally larger than a workgroup, typically between 25 and 100 persons. Each member of the workgroup has a desktop computer and the computers are linked by means of a local area network. Enterprise databases. The enterprise database is one which scope is the entire organization or at least many different departments. Such databases are intended to support organization-wide operations and decision-making. A single operational enterprise database is impractical for difficulties in performance, diverse needs of different users, and the complexity of achieving a single definition of data for all database users. An enterprise database does, however, support information needs of many departments. The most important type of enterprise database today is called a data warehouse. A data warehouse is an integrated decision support database whose content is derived from the various operational databases such as personal computer, workgroup, and department databases. The enterprise databases are implemented on local area network or wide area network. Consider a large healthcare organization that operates a group of medical centers including hospitals, clinics, and nursing homes. Each of these medical centers may have separate databases to support the various operations at that facility. These databases contain data concerning patients, physicians, medical services, business operations, and other related entities. The databases provide adequate support for most functions at each individual medical center. However, the organization has increasingly realized the need for a single consolidated view of the entire organization. This body of data is required for corporate decision making. Therefore, the organization creates a data warehouse maintained at the corporate office. Data in the data warehouse are derived by extracting and summarizing data from the individual databases on a periodic basis and transmitting those data by means of a telecommunications network to the corporate data warehouse. Advantages of database approach. Now we will discuss major advantages of using database approach. These are data independence. The data modification is a normal practice in any organization, such as increase in the salary. Therefore, it is wise to keep data separate from the application programs that use it. This separation of data from the application program is called data independence. Dear learners, as you know that with the database approach, data is stored at a central location called repository. This property of database system allows an organization's data to change within limits without changing the application programs that process the data. Consider a computer program to calculate the bonus, which is currently 5% of monthly sale. If the rate of bonus is raised to 7%, then the computer program is required to change to incorporate the change in the data. The program needs to be recompiled and run. This change of software is useless and can be avoided by storing the data separately in the database as shown. Now, if there is any change in the data, that is 7% raise of bonus rate is modified easily in the database without changing the actual software. Minimal data redundancy. Data redundancy means a data item is stored at multiple locations. For example, record of students is stored in the examination department as well as in the academic department he or she is studying in. Dear learners, as you know that database is a shared resource. Therefore, the student records are stored at a common location and is accessed by examination department as well as academic department. Now it becomes clear that adopting database approach controls the duplication of data. Improve data consistency. Eliminating or controlling data redundancy, we greatly reduce the opportunities for inconsistency. For example, if address of a particular student is stored only once, there is no disagreement on the stored value. Also, updating data values is greatly simplified when each value is stored in one place only. Improve data sharing. Dear learners, as you know, the database is a shared corporate resource. Authorized users are granted permissions to use the database. Increase productivity of application development. There are a number of productivity tools available such as query languages, forms, and report generators. These tools greatly reduce the cost and time for developing new business applications. Enforcement of standards. When the database approach is implemented with full management support, the database administration function should be granted single point authority and responsibility for establishing and enforcing data standards. These standards will include naming conventions, data quality standards, and uniform procedures for accessing, updating, and protecting data. The data repository provides database administrators with a powerful set of tools for developing and enforcing these standards. Improve data accessibility and responsiveness. Dear learners, as you know, the data is stored for a reason that it must be available when needed in various forms. The user requirements may have many forms related to stored data. For example, head of department needs to know the top position in a particular course. Next moment, he may need to know the average result of that course. The data once stored in a database can be quickly accessible and can be manipulated accordingly. Reduced program maintenance. The updating of stored data is a frequent practice for a variety of reasons. New data items are added, data formats are changed, and so on. In a database environment, data are more independent of the application programs that use them. Within limits, we can change either the data or the application programs that use the data without necessitating a change in the other factor. As a result, program maintenance can be significantly reduced in a modern database environment. Costs and risks of database approach. The database approach entails some additional costs and risks that must be recognized and managed. These are new specialized personnel. Frequently, organizations that adopt the database approach need to hire or train individuals to design and implement databases and to provide database administration services. Because of the rapid changes in technology, newly hired people will have to be retrained or upgraded on a regular basis. An organization must not minimize the need for these specialized skills. Installation and management cost and complexity. A multi-user database management system is a large and complex suite of software that has a high initial cost, requires a staff of trained personnel to install and operate, has substantial annual maintenance and support costs. Installing such a system may also require upgrades to the hardware and data communication systems in the organization. Substantial training is normally required on an ongoing basis to keep up with new releases and upgrades. Additional or more sophisticated and costly database software may be needed to provide security and to ensure proper concurrent updating of shared data. Conversion costs. The term legacy system is widely used to refer older applications in an organization based on older database technology. The cost of converting these older systems to modern database technology is measured in terms of money, time, and organizational commitment. Need for explicit backup and recovery. A shared corporate database must be accurate and available at all times. This requires comprehensive procedures for providing backup copies of data and for restoring a database if damage occurs. Organizational conflict. A shared database requires a consensus on data definitions and ownership, responsibilities for accurate data maintenance. Experience has shown conflict on data definitions, data formats and coding, rights to update shared data. All these issues are frequent and often difficult to resolve. Handling these issues requires an organizational commitment. Components of database environment. Dear learners, the major components of a typical database environment and their relationships are computer-aided software engineering tools. These are automated tools used to design and develop databases. Repository, centralized storehouse for all data definitions, data relationships, screen, report formats, and other system components. A repository contains an extended set of metadata important for managing databases as well as other components of an information system. Database management system. Commercial software systems are used to define, create, maintain, and provide controlled access to the database and also to the repository. Database, an organized collection of logically related data usually designed to meet the information needs of multiple users in an organization. It is important to distinguish between the database and the repository. The repository contains definitions of data, whereas the database contains occurrences of data. Application programs. The computer programs used to create and maintain the database and provide information to users. User interface. Languages, menus, and other facilities by which users interact with various system components such as case tools, application programs, the DBMS, and the repository are called user interface. Data administrators. The data administrators are persons responsible for the overall information resources of an organization. They use case tools to improve the productivity of database planning and design. System developers. The system developers are persons such as system analysts and programmers who design new application programs. System developers often use case tools for system requirements analysis and program design. End users. Persons throughout the organization who add, delete, and modify data in the database and who request or receive information from it. Data. Dear learners, After discussing the database definition, types, cost, and components of database, now it is time to discuss the backbone of database, that is, data. Historically, the term data referred to known facts that could be recorded and stored. The word data refers to facts concerning things such as people, objects, or events. For example, list of students as shown. Similarly, in a salesperson's database, the data would include facts such as customer name, address, and telephone number. This definition now needs to be expanded to reflect a new reality. Databases today are used to store objects such as documents, photographic images, sound, and even video segments, in addition to conventional textual and numeric data. For example, the salesperson's database might include a photo image of the customer contact. It might also include a sound recording or video clip of the most recent conversation with the customer. To reflect this reality, we use the following broadened definition. Data consists of facts, text, graphics, images, sound, and video segments that have meaning in the user's environment. Information. The data is raw collection of facts and figures related to something. This can be useful only if refined and reflects a meaning. This refined shape of data is called information. It is knowledge derived from data. For example, the given table gives us information that is 2 students enrolled in database major, 1 student enrolled in networking, and 1 student enrolled in programming. Metadata. We just learned that data become useful only when placed in some context. The primary mechanism for providing context for data is metadata. Metadata are data that describe the properties or characteristics of other data. Some of these properties include data definitions, data structures, and rules or constraints. For example, in the given table, the registration number, name, class, and city are the metadata. Entity. Every system is composed of many objects, such as persons and events. For example, a university is composed of employees, students, courses, course registrations, etc. The individual object in a system is called an entity class or entity type. The individual entities are sometimes very large in numbers in a system. For example, students in the university are usually large in numbers. The large number of entities is very difficult to manage. Therefore, such large number of entities is always grouped, which is called an entity class. Every entity always belongs to an entity class. An entity may belong to more than one entity class. For example, a faculty member belongs to employee class as an employee, as well as may belong to a student class if registered for PhD degree program. Similarly, a physician in a hospital belongs to physician class as a physician, as well as may belong to patient class if hospitalized. Attributes. Each entity type has a set of attributes associated with it. An attribute is a property or a characteristic of an entity type that is of interest to the organization. For example, the entity type student has attributes registration number, name, address, and phone number. Similarly, the entity type automobile has attributes registration number, color, type, and model. Let us now discuss recommendations for naming the attributes. Use an initial capital letter followed by lowercase letters. For example, name, registration number. If an attribute name consists of 2 words, an underscore character is used to connect the words. Each word is started with a capital letter. For example, employee name. The actual values are assigned to attributes of an entity class. No value can be stored without attributes for an entity. Each instance of an entity type has a value associated with each of the attributes of that entity type. This is shown as: there are 2 entities in the given entity class student with their respective attribute values. Types of attributes: simple versus composite attributes. Some attributes can be broken down into meaningful components. The most common example is address, which can be broken down into components such as street number, house number, town, and city. Composite attributes provide considerable flexibility to users. It can either be referred as single unit or referred as its individual component. A simple or atomic attribute is an attribute that cannot be broken down into components. For example, all of the attributes associated with automobiles are simple: registration number, color, type, and model. Single-valued versus multi-valued attributes. A single-valued attribute has one value for an entity in an entity class, while multi-valued attribute has more than one value for an entity in an entity class. Consider the entity class student. There are two entities with their respective attribute values. For each entity instance, the attribute registration number, name, and program has one value, that is, attribute registration number has value 1, attribute name has value Arsalan, and attribute program has value BS. Such types of attributes are called single-valued attributes. It frequently happens that an attribute may have many values for a given instance. For example, the entity type student has an attribute courses, which may have many values for an instance, that is, an instance with registration number 1, name Arsalan, and program BS registered 3 courses: DBMS, C++, and networking. Such types of attributes are called multi-valued attributes. Stored versus derived attributes. Stored attributes are those attributes whose values can be stored. The derived attributes are those whose values could be calculated from other related attributes and are not required to be stored. For example, the entity type student has a birth date attribute. If it requires knowing the age, it can be calculated using birth date and today's date. Now it is clear that a derived attribute is an attribute whose value can be calculated from stored attribute values. Key. An entity class may have a large number of entities. The recognition of single entity or group of entities in an entity class is very important. Look at the entity class student as shown. If it requires to know the program of a student, it becomes necessary to recognize the individual entity. Similarly, if it is required knowing all students belonging to city Peshawar, the group based on city becomes necessary to recognize. The key could be used to recognize the individual or group of entities in an entity class. Now it is time to define key. A key is a single attribute or a group of attributes used to recognize individual entity or group of entities in an entity class. For example, in entity class student, attribute registration number could be used to recognize an individual entity. Similarly, attribute city could be used to know the list of students belonging to Peshawar. Let us discuss key in more detail by discussing various types of keys. These are primary key. It is a single attribute used to recognize an entity in an entity class. For example, in entity class student, the attribute registration number is a primary key. The primary key attribute is represented as underline. Now a question arises: why attribute registration number is chosen as primary key? This can be clarified by discussing characteristics of attribute to be selected as primary key. These are: number 1, it is always defined. Number 2, it is only one. Number 3, it has unique value for every instance, and number 4, it must have a value. Composite key. It is group of attributes used to recognize single entity in an entity class. Thus, a composite key is basically a primary key composed of more than one attributes. For example, consider the entity class student as shown. In this example, any of the attribute cannot be used as primary key as duplication exists which is not allowed in case of primary key. Combining different attributes whose collective value shall recognize the single entity in an entity class can solve this problem, such as roll number plus shift recognize single entity in entity class student. Now let us discuss the characteristics of composite key, which are: number 1, it is always defined; number 2, it is only one; number 3, the collective value must be unique for every instance; number 4, the value of attributes of composite key is mandatory. Alternate key. It is single attribute other than the primary key, used to recognize single entity in an entity class. It is also called candidate key. Consider the example as shown. The attribute passport number is an alternate key by assuming that attribute registration number is defined as primary key. The characteristics of alternate key are: number 1, it is not defined; number 2, the value of attribute to be used as alternate key must be unique value for every entity instance; number 3, the value is not mandatory. Secondary key. It is a single attribute or group of attributes used to recognize group of entities in an entity class. Consider the entity class student as shown. The attribute city can be used as secondary key, knowing all the students belonging to Peshawar. Any part of the composite key can also be used as secondary key. For example, in the entity class student as shown, the attribute shift can be used as secondary key, knowing all the students of morning shift or evening shift. The characteristics of secondary key are: number 1, it is not defined; number 2, it may be more than one; number 3, the primary key or composite key cannot be used as secondary key; and number 4, any part of the composite key can be used as secondary key. Sort key. It is a single attribute or group of attributes used to organize and access group of entities efficiently. Consider the example as shown. If it is required to access all students belonging to Islamabad, the search is started from first entity and continues sequentially till the end of entities. All the entities matching the criteria are accessed. It takes long time and all the entities must be read and compared against the desired access. This longer access can be made efficient by organizing the entities by desired attribute such as city in student entity class. The organized entities are shown as: now if it is required to access all students belonging to Islamabad, the search is started from first entity and continues sequentially till the last matching entity. All the entities matching the criteria are accessed. The remaining entities are not searched for desired entities, as there is no chance for such existence. Dear learners, remember that only secondary key attribute can be used as sort key. Index key. It is an attribute used to access a single entity efficiently from an entity class. Consider the entity class student as shown. If it is required accessing Daniel, whose registration number is 2, the search is started from first entity and continues sequentially till the desired matching entity or end of entities encountered. The desired entity is found in fifth matching. The same desired entity could be accessed by organizing the entities on primary key or composite key or alternate key, such as attribute registration number in entity class student. The organized entities are shown as: now if it is required accessing Daniel, whose registration number is 2, the search is started from first entity and continues sequentially till the desired matching entity or end of entities encountered. The desired entity is found in second matching. Thus, the number of matches are reduced. Data association. Dear learners, as you know that every system is composed of entity classes which are not isolated from one another. Therefore, they interact with one another. This interaction builds useful systems in the real world. This logical link of one entity class with another entity class is called data association. Now it is clear that an isolated entity class is meaningless and not productive. For example, The entity student is linked with entity class faculty member, as well as courses and many other. The logical link is represented graphically as shown. Now let us discuss various types of association in detail. One-to-one association. An instance of one entity class A can be associated with exactly one instance of another entity class B. The graphical representation is shown as. Consider the example by assuming that a student can take only one project in the final semester. This is represented graphically as shown. The sample instances are shown as. The student Arsalan takes project examination system. The student Daniel takes project admission system. The student Fawad takes project fee system. One-to-many association. An instance of one entity class A can be associated with many instances of another entity class B. The graphical representation is shown as. Consider the example by assuming that a project can be taken by many students in the final semester. This is represented graphically as shown. The sample instances are shown as. The project examination system is taken by students Arsalan and Daniel. The project admission system is taken by a student Khalid. The project fee system is taken by students Fawad and Sana. Many-to-many association. Many entities of one entity class A can be associated with many entities of another entity class B. The graphical representation is shown as. Consider the example by assuming that many students take many courses. The sample instances are shown as. The student Arsalan takes 3 courses, C++, DBMS and Java. The student Khalid takes 3 courses, C++, networking and communication. The student Fawad takes 2 courses, Java and operating system. Data structure diagram. The logical link of entity classes is not restricted to 2 entity classes. Rather, it can be extended to any number of entity classes, which collectively build systems. The graphical representation of such entity classes is called a data structure diagram. Consider the example. A customer orders for many products. A product may be ordered by a number of customers. In this example, there are 3 entity classes: customer, order, and product. The data structure diagram is shown as. Dear learners, so far we studied that the entity classes of any system have logical link with one another. This logical relationship is the theme of this unit. Introduction. This unit describes the basic architecture of entity relationship model. It also focuses on modeling of various types of entity classes and the development of complete entity relationship model. History of various data models and the current trends on which database design is based. It also focuses on the basic database design derived from entity relationship model. Objectives. The objectives of the unit are to understand architecture of entity relationship model, various types of relationships, how the complexities of relationship are handled, the effect of cardinality in relationships, how multi-valued attributes are modeled, how time-dependent attributes are modeled, how associative entity types are modeled, hierarchical data model, network data model, relational data model, why relational data model is in use, and the basics of database design. The ER model. An entity relationship model, also called ER model, is a detailed logical representation of the data. It is expressed in terms of entity classes in the business environment, the relationship or associations among those entity classes along with their attributes. An ER model is normally expressed as an entity relationship diagram, commonly referred as ER diagram, which is a graphical representation of an ER model. ER model notations. Let us now discuss the symbols which are used to develop the ER model. These are Rectangle. The entity class is represented by a rectangle. The name of entity class is written inside, as shown. For example, the entity class student is represented as shown. Oval. The attributes are represented as an oval-shaped symbol. The name of attribute is written inside, as shown. For example, the attribute name is represented as shown. Dear learners, let us discuss the representation of different types of attribute. These are multi-valued attribute. The multi-valued attribute is represented by double oval-shaped symbol. The name of attribute is written inside, as shown. For example, the multi-valued attribute courses are represented as shown. Derived attribute. The derived attribute is represented by dashed oval-shaped symbol. The name of attribute is written inside, as shown. For example, the derived attribute age is represented as shown. Primary key attribute. The primary key attribute is represented as an oval-shaped symbol. The name of attribute is underlined and written inside, as shown. For example, the attribute registration number is represented as shown. Composite key attribute. Each attribute of composite key is represented by an oval-shaped symbol with underlying the attribute name written inside, as shown. For example, the attributes roll number and shift are shown as composite key. The ER model. An entity relationship model, also called ER model, is a detailed logical representation of the data. It is expressed in terms of entity classes in the business environment, the relationship or associations among those entity classes along with their attributes. An ER model is normally expressed as an entity relationship diagram, commonly referred as ER diagram, which is a graphical representation of an ER model. ER model notations. Let us now discuss the symbols which are used to develop the ER model. These are rectangle. The entity class is represented by a rectangle. The name of entity class is written inside, as shown. For example, the entity class student is represented as shown. Oval. The attributes are represented as an oval-shaped symbol. The name of attribute is written inside, as shown. For example, the attribute name is represented as shown. Dear learners, let us discuss the representation of different types of attribute. These are multi-valued attribute. The multi-valued attribute is represented by double oval-shaped symbol. The name of attribute is written inside, as shown. For example, the multi-valued attribute courses are represented as shown. Derived attribute. The derived attribute is represented by dashed oval-shaped symbol. The name of attribute is written inside, as shown. For example, the derived attribute age is represented as shown. Primary key attribute. The primary key attribute is represented as an oval-shaped symbol. The name of attribute is underlined and written inside, as shown. For example, the attribute registration number is represented as shown. Composite key attribute. Each attribute of composite key is represented by an oval-shaped symbol with underlying the attribute name written inside, as shown. For example, the attributes roll number and shift are shown as composite key. Dear learners, after types of attribute representation, the next symbol of ER model is straight lines. Recall, we learned previously that attributes are the defined properties of an entity class. This means that attributes are always associated with an entity class. The straight lines are used to connect attributes to an entity class, as shown as, for example, the entity class student has 3 attributes: registration number, name, and address. These are connected by straight lines, as shown. Diamond. Recall once again, we learned previously that entity classes are logically connected or related with one another. This relationship is very important in the database design and implementation. It is the glue that holds together various entity classes of an ER model. The relationship in ER model is represented as diamond-shaped symbol. The name of relationship is written inside, as shown. For example, the relationship named register is represented as shown. Now it is time to show a simple example of ER model. Consider the statement. A student is allowed to register a project in the final semester. The business rule is only one student can register a given project. There are two entity classes. These are student. Let the attributes are registration number, which is the primary key, and name. Project. Let the attributes are code, which is the primary key, and title. This situation can be represented in ER model, as shown. The relationship register acts as glue through straight lines to connect entity class student with attributes registration number and name, another entity class project with attributes code and title. Dear learners, the type of association changes in ER model if the business rules are changed. This is discussed here. Let us change the business rule for the problem stated just before, that many students are allowed to register a given project in the final semester. This situation is represented in ER model as shown. The type of association is changed to one to many. Now let us change the business rule once again, as many students are allowed to register many projects in the final semester. This situation is represented in ER model as shown. This time the type of association is changed to many to many. Types of relationship. Dear learners, the relationship discussed previously takes many forms, which are discussed here. Unary relationship. It is relationship between instances of same entity class. It means that only one entity class is associated with a given relationship. The unary relationship is also called recursive relationship. The general representation in ER model is shown as, for example, one employee that is manager manages another employee that is staff or worker. The manager and staff or worker both belong to employee entity class. There is a relationship named manage. The ER model is shown as, it shows that one instance of entity class employee that is manager manages another instance of the same entity class that is staff. Binary relationship. It is relationship between instances of one entity class with instances of another entity class. It means that two entity classes are involved in a given binary relationship. It is represented in ER model as shown as, for example, a customer places an order. There are two entity classes, customer and order. There is a named relationship, place. The ER model is shown as, the relationship place connects logically the entity class customer with entity class order. Ternary relationship. It is relationship between instances of three entity classes with one another. It means that three entity classes are involved in a given ternary relationship. It is represented in ER model as shown. For example, many students registered many courses and many faculty members teach many courses. The ER model is shown as, in this model, the relationship takes connect logically three entity classes, student, course, and faculty member. Dear learners, the number of entity classes for a given relationship is not restricted to 3, but rather any number of entity classes can be used. Degree of relationship. The degree of a relationship is the total number of entity classes that participate in that relationship. Dear learners, look at these examples. Example number 1. The relationship manage has only one entity class, that is employee. Therefore, the degree of relationship manage is 1. Example number 2. The relationship place has two entity classes that are customer and order. Therefore, the degree of relationship place is 2. Example number 3. The relationship takes has three entity classes that are student, faculty, and course. Therefore, the degree of relationship takes is 3. Dear learners, The degree of a relationship is not restricted to 3, but the degree of a relationship beyond ternary is considered being a poor practice, as it increases complexity. Therefore, the higher degree relationship are advised to decompose in order to make it simple. Let us now discuss how the higher degree relationship create complexity by taking this example as shown. Look at the ER model. The degree of relationship takes is 4 as there are 4 entity classes involved. These are number 1 student, number 2 faculty, number 3 project, number 4 course. The complexity can be easily judged by reading the model as many students registered many courses, many students registered for many projects. Many faculty members are assigned many courses. Many faculty members supervise many projects. The single relationship is sometimes difficult to name. Moreover, the relationship takes shows a direct relationship between entity classes, project, and courses, which does not exist actually. The relationship takes may be decomposed as shown. Look at the modified version of degree 4 relationship takes. The relationship register connects entity class student with entity class course, as many students register many courses. The relationship takes connects 3 entity classes, student, project, and faculty, as many students register many projects and projects are taken by many faculty members. The relationship assignment connects entity class course with entity class faculty, as many courses are assigned to many faculty members. Cardinality. Cardinality is the number of instances of one entity class that could associated with each instance of another entity class. Let us now discuss cardinality in more detail by discussing various types of cardinality. These are mandatory cardinality and optional cardinality. The mandatory cardinality is further divided into mandatory one and mandatory many. Similarly, the optional cardinality is also further divided into optional one and optional many. Let us now discuss each one in detail. Mandatory cardinality. If minimum instances of an entity class are 1 for a defined relationship, it is said to be a mandatory cardinality. For example, a student must register minimum of 1 course in a semester. The cardinality of entity class course is said to be mandatory. Mandatory 1 cardinality. The mandatory cardinality is said to be mandatory 1 if both minimum and maximum instances are 1 in a relationship. The general form of mandatory cardinality is shown as, for example, consider a statement that a student must take a project in the final semester and moreover, a given project is taken by only one student. Look at the ER model as shown. The cardinality of entity class student is mandatory 1 as the minimum and maximum value of a student is 1 in the relationship takes. Similarly, the cardinality of entity class project is mandatory 1 as the minimum and maximum value of a project is 1 in the relationship takes. Mandatory many cardinality. The mandatory cardinality is said to be mandatory many if minimum instance is 1 and maximum instances are more than 1 in a relationship. The general form of mandatory cardinality is shown as, for example, consider a statement that a faculty member must take minimum of 1 course but may take more than 1 courses. Moreover, a given course is taken by only one faculty member. Look at the ER model as shown. The cardinality of entity class course is mandatory many as the minimum course value is 1 and maximum course value is many in the relationship teach. Dear learners, the many in mandatory many cardinality may be a defined number that is 3. It is represented as shown, where n is any positive integer greater than 1. Dear learners, let us now discuss optional cardinality in detail. The cardinality is said to be optional if minimum number of instances of an entity class is 0 in a defined relationship. For example, a faculty member may not take any course in a semester. Thus, the cardinality of entity class faculty member is optional. Let us now discuss its types. Optional 1. The optional cardinality is said to be optional 1 if minimum instances are 0 and maximum instances are 1 of an entity class in a relationship. The general form of optional 1 cardinality is shown as, for example, consider a statement that a faculty member may not take any course in a semester or may take maximum of one course. Look at the ER model as shown. The cardinality of entity class course is optional 1 as the minimum course value is 0 and maximum course value is 1 in the relationship take. Optional many. The optional cardinality is said to be optional many if minimum instances are 0 and maximum instances are many of an entity class in a relationship. The general form of optional many cardinality is shown as, for example, consider a statement that a faculty member may not take any course in a semester or may take many courses. Look at the ER model as shown. The cardinality of entity class course is optional many as the minimum course value is 0 and maximum course value is many in the relationship take. Modeling multi-valued attributes. Dear learners, let us consider instances of a multi-valued attribute phone before its modeling, as shown as. The analysis shows these drawbacks. Number 1. The attribute registration number is supposed to be a primary key, but due to existence of multi-valued attribute phone, it could not be defined. Number 2. There is redundancy due to existence of multi-valued attribute phone, that is name Daniel is placed 3 times because having 3 phone numbers. Thus, adding value of phone number creates redundancy, which is considered one of the major drawbacks. These problems can be resolved by adopting this general procedure. The multi-valued attribute is converted into new entity class. The newly created entity class have the composite key with primary key attribute of original entity class. Establish relationship between original entity class and newly created entity class. Dear learners, there are 2 possibilities for existence of multi-valued attributes. Each one is dealt in a different way. These are single multi-valued attribute. If there is only one multi-valued attribute in an entity class, then it is converted into separate new entity class. The class name and attributes are required to be defined. For example, consider the entity class student with 2 single-valued attributes, registration number and name, and 1 multi-valued attribute phone as shown. The multi-valued attribute phone number is converted into new entity class phone as shown. The newly created entity class phone has 2 attributes, registration number and phone number. Both attributes collectively form composite key. The relationship have is established between original entity class student and newly created entity class phone. Dear learners, this modeling of multi-valued attribute introduces new types of entity classes. These are associative entity class. The entity class with composite key or have existence dependency is called associative entity. The associative entity class is also called weak entity class. It is represented by a rectangle with lines. Regular entity class. The entity class with the primary key or on which associative entity class is dependent is called regular entity class, as shown. Dear learners, let us now discuss how many multi-valued attributes are dealt. There are 2 possibilities for existence of many multi-valued attributes in an entity class. Let us now discuss each in detail. Logically related multi-valued attributes. Many multi-valued attributes that are logically related with one another form a group called repeating group. These procedural steps are adopted to model a repeating group. Number 1. The repeating group is converted into new entity class. Number 2. The multi-valued attributes of original entity class become the attribute of newly created entity class. Number 3. The newly created entity class must have the composite key with primary key attribute of original entity class. Number 4. Establish relationship between original entity class and newly created entity class. Let us examine entity class faculty as shown. It has 2 single-valued attributes, faculty code and name, and two multi-valued attributes, project code and registration number. This model shows a faculty member supervises a number of software projects taken by students. Let us now examine how entity class faculty is modeled. The steps involved are: the two multi-valued attributes project code and registration number are logically related, thus form a repeating group. This repeating group is converted into new entity class project. Number 2. The multi-valued attributes of original entity class, that are project code and registration number, become attributes of newly created entity class project. Number 3. The newly created entity class, that is project, have composite key composed of attributes project code and faculty code. The attribute faculty code is the primary key attribute of original entity class, that is faculty. Number 4. The relationship takes is established between original entity class, that is faculty, and newly created entity class project. Not logically related. Dear learners, let us now discuss the second possibility for existence of many multi-valued attributes in an entity class. Here is the detail. If there are many multi-valued attributes in an entity class not logically related, then these procedural steps are adopted to model. Number 1. Convert each multi-valued attribute into a new entity class. Number 2. The newly created entity classes must have composite key with primary key attribute of original entity class. Number 3. Establish relationship between newly created entity classes and the original entity class. Let us examine entity class student as shown. It has two single-valued attributes, registration number and name, and two multi-valued attributes, course and hobby. This model shows a student may register many courses and also have many hobbies. It is important to note that the course registration has no bearing on hobbies. Let us now examine how entity class student is modeled. The steps involved are: Number 1. The multi-valued attribute course is converted into new entity class course. Similarly, multi-valued attribute hobby is converted into new entity class hobby. Number 2. The newly created entity class course has composite key composed of attributes, course code and registration number. Similarly, the newly created entity class hobby has composite key composed of attributes, course code and hobby code. The attribute registration number in both the entity classes is the primary key of original entity class, that is student. Number 3. The relationship have is established between original entity class, that is student, and two newly created entity classes, that are course and hobby. Modeling time-dependent data. Updating of data with the passage of time is frequently required in information systems. Sometimes previous versions of data values are required for future reference. Such type of data whose values are updated with the passage of time and the history of changed values is kept is called time-dependent data. For example, the fee per credit hour in a semester for BS program is Rs 1200, effective from spring 2002 semester. The total fee is calculated by multiplying number of credit hours registered with Rs 1200. Let the fee per credit hour is raised by Rs 500 with effect from autumn 2002 semester. The fee of a student in a subsequent semester is calculated at the rate of per credit hour effective at the time of admission. In this case, the fee rate is revised with the passage of time and the history of changes is required to keep. This data item is time dependent. The time dependent data always makes a repeating group. The entity class fee is shown as: it has two single-valued attributes, fee code and description, and two multi-valued attributes, rate and effective date. Let us now examine how entity class fee is modeled. The steps involved are: Number 1. The two multi-valued attributes, rate and effective date, are logically related, thus form a repeating group. This repeating group is converted into new entity class history. Number 2. The multi-valued attributes of original entity class, that are rate and effective date, become attributes of newly created entity class, that is history. Number 3. The newly created entity class, that is history, has composite key composed of attributes fee code and effective date. The attribute fee code is the primary key attribute of original entity class, that is phi. Number 4, the relationship has is established between original entity class, that is phi, and newly created entity class history. Gerund. The relationship of type many-to-many between entity classes when converted into an entity class is called gerund. It is also called associative entity. The reason of converting such a relationship into an entity class is discussed in the subsequent example. Here is the example. Many students register many courses in a given semester. The formation of gerund is given stepwise. As step 1, the single entity class student is shown as it has two single-valued attributes, registration number and name, and two multi-valued attributes, course code and title. There is high degree of redundancy due to existence of multi-valued attributes, course code and title. These multi-valued attributes need a refinement, as in step number 2. The multi-valued attributes are converted into associative entity course with attributes, registration number, course code and title, as shown. Let us examine this refined modeling. The redundancy pointed out in step 1 is reduced as the name of student is stored once, even registered in many courses. But the entity course has still a redundancy, that is, the title C++ is duplicated. Dear learners, it is a point to think why there is redundancy. The reason for this redundancy is the existence of relationship register of type many-to-many between entity classes student and course. Now it is time to learn how such problems are solved. Here is the detail. Whenever there is a relationship of type many-to-many, it is converted into new entity class called associative entity, also called gerund, such that there must be a composite key which must be constructed by the primary keys of all associated entity classes. It may also have non-key attributes. The general representation of associative entity is shown as. Dear learners, the model as shown is refined further in order to control redundancy as shown. The relationship register is converted into associative entity with attributes, registration number and course code, which collectively forms a composite key. Now let us evaluate the model for any redundancy as existed before. The name of any student is stored once, no matter how many courses does he register. Similarly, the course title is stored once, no matter how many students register that course. Thus, the gerund or associative entity greatly controls redundancy. Dear learners, the gerund may also have non-key attributes as shown. Super and subtypes. Dear learners, let us first discuss the concept of super and subtype. In most business applications, the entity classes are subdivided into subclasses. This subdivision is generally done for easy administration and management. For example, a university is considered as an entity class university. This entity class as a whole is very complex and difficult to administer. Therefore, it is further subdivided into subclasses that are academic, administration, finance, examination, and many more. The generic entity class, which is further subdivided into subclasses, is called supertype, and each subclass of a superclass is called subtype. The ER representation of super and subtype is shown as. Let us consider this example. There are two types of faculty members as regular and visiting. The attributes of regular faculty member are employee code, employee name, designation, and salary per month. The attributes of visiting faculty members are employee code, name, teaching rate per hour, and contract period. Dear learners, now it is time to examine how the given situation is modeled. Let us model it on the basis of what we learned previously. There are two choices for depicting the ER model. Number 1, define one entity class faculty member as shown. Number 2, define entity class regular for regular faculty and visiting for visiting faculty as shown. Let us examine both the models. The single entity class faculty member has a drawback that there are some attributes which are not applicable to every faculty member. For example, the attribute designation is not applicable to an instance of faculty member of the type visiting, as shown. The two entity classes that are regular and visiting has a drawback, that common attributes that are employee code and name are defined with each entity class. Thus, the commonly existed attributes are defined redundantly. Dear learners, now what must be done to resolve the stated problem with each model? The concept of super and subtype discussed is the key to refine the stated models. The super and subtypes are modeled as: define supertype with attributes common to all defined subtypes. Define subtypes with attributes unique to each subtype. Now let us use the concept of super and subtype in the stated model. Define supertype faculty member and subtypes regular and visiting. The attributes of supertype faculty member are employee code as primary key and name. The attributes of subtype regular are designation and salary. Similarly, the attributes of subtype visiting are as primary, rate per hour and contract period. Dear learners, dealing with super and subtypes, it must be kept in mind that an instance of subtype is always a member of an instance of supertype. The subtype inherits values of all attributes of supertype. So far, we learned that a generic entity is modeled as super and subtypes if all subtypes have unique properties. But what about a generic entity if subtypes have same attributes? Dear learners, such type of a generic entity is modeled as single entity class with an additional attribute for differentiating the type. For example, consider the situation. There are two types of students studying in morning shift or evening shift. The attributes of student are registration number, name, and city. The student entity class must not be modeled as super and subtype, but rather be modeled as single entity class as shown. The attribute shift is an additional attribute defined to differentiate the type of student either morning or evening. Specialization and generalization. Dear learners, so far we discussed the basic principles of super and subtypes modeling. But in developing real-world data models, how can we recognize the opportunities to explore the super and subtype relationship? There are two processes which serve as mental model in developing super and subtypes relationships. These are generalization, specialization. Let us discuss each one in detail. Generalization. In data modeling, the generalization is the process of defining a more general entity from a set of more specialized entity types. For example, consider these three entity types as shown. The entity car has attributes vehicle identification number, color, price, and engine capacity. The entity motorcycle has attributes vehicle identification number and price. The entity truck has attributes vehicle identification number, price, and maximum load. It becomes clear by closely examining these entities that the attributes vehicle identification number and price are common. This fact reiterates that each of the given entity types is a version of more general entity type vehicle as shown. The subtype car has attributes color and engine capacity. It inherits all attributes of its supertype vehicle as it is an instance of it. Similarly, the subtype truck has attribute maximum load. It also inherits all attributes of its supertype vehicle as it is an instance of it. Dear learners, the entity type motorcycle is missing here. Is this simply an omission? No, it is deliberately not included because it does not satisfy the condition for a subtype, that is, the motorcycle entity type does not have unique attribute, which is necessarily be present for existence as subtype of a supertype. The absence of motorcycle entity type also shows that an instance of a supertype is not necessarily be a member of any of the defined subtypes. This is discussed further in the next section. Let us now discuss the second process of mental model in developing super and subtypes relationships, that is, specialization. In data modeling, the specialization is the process of defining one or more subtypes of the supertype and forming super and subtype relationship. For example, consider the entity type vehicle. The attributes are vehicle identification number as primary key, price, color, engine, capacity, and maximum load. After further discussion with user of these vehicles, it is discovered that two types of vehicles are used. Each has unique attributes. The domain of stated problem clearly demonstrates that the most general entity type vehicle shall be decomposed into more specialized subtypes, each with unique attributes as shown. Dear learners, now it is clear that generalization and specialization are two techniques used for modeling of super and subtypes. These are summarized as: the generalization technique is bottom-up approach while the specialization technique is top-down approach. The application of either of these techniques depends upon nature of problem domain, previous modeling efforts, if any, and maybe personal preferences. Constraints in super and subtypes relationships. Dear learners, so far we discussed the basic principles of super and subtypes modeling and concept of generalization and specialization. But very often there are constraints which help to apply important business constraints to super and subtype relationships. These are completeness constraint and disjointness constraint. Let us discuss each in detail. The completeness constraint addresses the question whether an instance of a supertype must also be a member of at least one subtype. The completeness constraint has two specialization rules. These are total specialization and partial specialization. Let us discuss each one in more detail. The total specialization rule specifies that each instance of supertype must be a member of some subtypes of the supertype. The general representation is shown as the two parallel lines that join supertype entity to small circle shows that total specialization. For example, consider there are two types of employees that are regular and contract. Each type has some common attributes and unique attributes. The common attributes are employee code as identifier, name, and designation. The unique attributes of regular employee are basic salary, annual increment, and allowances total. The unique attributes of contract employee are total salary and contract period. Dear learners, in order to model this example, we first analyze it on the basis of our previous learning as the problem domain shows that super and subtype relationship must be applied to model it, and either of specialization or generalization technique could be used. The problem domain also shows that an employee that is an occurrence of supertype is necessarily be either of the two defined subtypes that are regular or contract, but never both at the same time, and there is no other type. This shows that total specialization rule is applied. The super and subtype model of the stated problem is shown as. Dear learners, let us now discuss the second rule of completeness constraint, that is partial specialization. The partial specialization rule specifies that an instance of supertype does not belong to any of the defined subtypes. The general representation is shown as the single line that joins the supertype entity to a small circle shows the partial specialization. For example, let us modify the employee example just discussed in total specialization as the organization generally has two types of employees, regular and contract. However, there may be other types also, such as hourly paid. Dear learners, in order to model this time, we first analyze it on the basis of our previous learning as the problem domain shows that super and subtype relationship must be applied to model it, and either of specialization or generalization technique could be used. The problem domain shows that an employee that is an occurrence of supertype is not necessarily belong to either of the two defined subtypes that are regular or contract, but may also be of other undefined type. This shows that partial specialization rule is applied. The super and subtype model of the stated problem is shown as. Dear learners, after discussing the completeness constraint, now let us discuss the disjointness constraint. The disjointness constraint addresses the question whether an instance of supertype simultaneously is a member of two or more subtypes at the same time. It has two rules. These are disjoint rule and overlap rule. Let us discuss each in more detail. The disjoint rule specifies that an instance of supertype must match to only one of the subtypes, either defined or undefined. It is represented in two ways, as shown. The small circle with D inside shows disjoint rule. The parallel lines show that there is no other subtype except the defined subtypes. For example, let us modify slightly the employee example discussed earlier in total specialization. Here is the modified model as shown. The employee is the supertype entity with common attributes employee code as identifier, name and designation. There are two subtypes: regular with unique attributes basic salary, annual increment and allowances total, and contract with unique attributes total salary and contract period. The model shows that an instance of employee is necessarily matched with either of the two defined subtypes, regular or contract. Dear learner, this is second representation. The small circle with D inside shows disjoint rule. The single line shows that there may also be subtypes other than the defined subtypes. For example, let us once again modify the employee example discussed in total specialization. Here is the modified model as shown. The employee is the supertype entity with common attributes employee code as identifier, name and designation. There are two subtypes: regular with unique attributes basic salary, annual increment and allowances total, and contract with unique attributes total salary and contract period. The model shows that an instance of employee is necessarily matched with either of the defined subtypes, regular and contract, or any other subtype not defined. Dear learners, after discussing the disjoint rule, now it is time to discuss the overlap rule. The overlap rule specifies that an instance of supertype may match to one or more of the subtypes, either defined or undefined. It is also represented in two ways as shown. The small circle with O inside shows overlap rule. The parallel lines show that there is no other subtype except the defined subtypes. For example, consider there are three types of sport teams, that are cricket, hockey and football in a sport club of a college. Each team has some unique attributes. Every member of the sport club is allowed to be member of more than one team. Here is the ER model. The model shows that an instance of sports club is necessarily matched with one or more of the defined subtypes: hockey, cricket or football. Dear learner, the second representation of overlap rule is shown as the small circle with O inside shows overlap rule. The single line shows that there may be other subtypes other than the defined subtypes. For example, let us modify the sports club example just discussed. There are three types of sport teams, that are cricket, hockey and football in a sports club of a college. Each team has some unique attributes. Every member of the sport club is allowed to be a member of more than one team and may be member of a team undefined as subtype, such as tennis. Here is the ER model. The model shows that an instance of sports club is necessarily matched with one or more of the defined subtypes: hockey, cricket and football, and other subtypes undefined, such as hierarchical data model. The hierarchical data model was the first data model used for database design and implementation. In this data model, the entity classes are organized as a set of nodes in hierarchical manner, like an inverted tree structure as shown. Here are few features of hierarchical data model. The entity classes are represented as a set of nodes. The entity classes are arranged in inverted tree-like structure starting from top node called root node. The nodes are linked physically through pointers with one another. The relationship among entity classes is parent-child. Dear learners, although hierarchical data model was very popular in the early era of database, however, the designer faced certain problems, such as the nodes insertion and deletion was very difficult, the model was pointer-based, it supported only one parent many child relationship, the model was rigid and static in nature, there was high degree of redundancy. But with the passage of time and advancement in the field, these problems were slightly overcome with the introduction of network data model. Network data model. In the network data model, the entity classes are organized as a set of nodes where any node could be connected or linked with any other nodes as shown. The network data model preferred over hierarchical data model because of less redundancy and elimination of one parent many child relationship. However, the designer was still faced with certain problems, such as number 1, the nodes insertion and deletion was very difficult. Number 2, the model was still pointer based. Number 3, the model was still rigid and static in nature. These problems were overcome with the introduction of Relation Data Model. Relational Data Model. Dr. E. F. Codd first introduced the Relation Data Model in 1970, and it is still in use. In this model, the entity classes are represented as a set of relations or tables as shown. The representation of table starts with the name of table, followed by column labels, separated by comma enclosed in parentheses. For example, the table named Student, having 3 columns, labeled registration number, name, and city as shown. The sample instances are shown as relation. Dear learners, let us discuss the term relation, also called table, in more detail. The relation is the basic building block of relation data model. The term relation is defined as it is a named, 2-dimensional set of data represented as unnamed rows and named columns. Every relation, whether simple or complex, has certain properties. These are: every relation has a unique name, the column names are unique within table, the value of each cell, that is intersection of a row and column, is atomic. There must be primary key or composite key, but never both at the same time. This ensures that every row is unique. The rows may be viewed in any required order. The columns may be viewed in any required order. Converting ER model into relations. Dear learners, let us now learn how entity relationship model is converted into database tables or relations. The entity relationship model is a primary source of designing database tables. If entity relationship model is modeled correctly, the database design will be perfect. Many case tools are available to design tables from ER model. However, it is important to know the conversion mechanism of ER model into set of tables. Let us now discuss it in detail. Dear learners, remember this general rule: in order to convert an ER model into tables, the entity class is converted into a table such that: number 1, name of the table is derived from name of entity class. It is preferred that the table have same name as entity class. Number 2, the attributes of entity class are converted into fields or columns of the table. Number 3, include keys. Dear learners, after knowing the thumb rule of entity class conversion into table, it is now time to explore it further. Here is the detail. Regular entity conversion. Each regular entity class is converted into a table such that the attributes of entity class are converted into fields or columns of the table. For example, let us see how the given entity class customer with attributes customer number, name, and city is converted into corresponding customer table. The entity class name, that is customer, is converted into table name customer. The attributes of entity class customer, that are customer number, name, and city, are converted into corresponding column names, that are customer number, name, and city. The sample rows are shown as. Let us now discuss conversion of composite attributes. If regular entity class has a composite attribute, then the atomic components of composite attributes are converted into columns as discussed earlier. For example, consider the entity class student with 2 atomic attributes, registration number and city, and 1 composite attribute, name, along with constituent parts, first name and last name. The entity class name student is converted into table name student. The atomic attributes registration number and city are converted into corresponding columns, registration number and city. The atomic parts of the composite attribute name, that are first name and last name, are converted into corresponding columns, first name and last name. Multi-valued attributes conversion. If regular entity class contains a multi-valued attribute, then 2 tables are created. The first table contains all the attributes of regular entity class except multi-valued attribute. The second table contains attributes with the primary key of first table along with multi-valued attributes of source entity. This table must have composite key. For example, consider the entity class student with 2 atomic attributes, registration number and name, and 1 multi-valued attribute, hobby. 2 tables are created as shown. Number 1, the entity class name, student is converted into table name student. The attributes of entity class registration number and name are converted into columns of table student. The column registration number is the primary key. Number 2, the multi-valued attribute hobby of entity class student is converted into table named hobby. The primary key attribute and multi-valued attribute of entity class student are converted into columns of table hobby. The column registration number and hobby makes the composite key. Associative entity conversion. If there is an associative entity, then it is converted into a table such that the primary key of regular entity is included as common attribute. The table resultant has a composite key with primary key of regular entity. For example, consider the entity class employee with two atomic attributes employee number and name and the entity class skill with an attribute skill. The entity class employee is converted into employee table with columns employee number as primary key name. The entity class skill is converted into skill table with columns employee number and skill with composite key. These tables are shown as. The sample rows are shown as. Dear learners, after learning conversion of various types of entity classes into tables, now it is time to discuss how these entity classes along with relationships are converted into tables. Let us first discuss entity classes of binary relationship. Every entity class with a binary relationship is converted into a table. The relationship between the tables is built by defining common attribute in both the tables. Let us now discuss various types of associations involved in binary relationship. One-to-one association. Consider the statement that a student is allowed to register for only one project and a given project is taken by only one student. The ER model is shown as. The given model is to be converted into table as. Step 1. Tables formation. The entity class student is converted into student table with attributes registration number as primary key and name as shown. Similarly, entity class project is converted into project table with attributes project code as primary key and title as shown. Step 2. Build relationship. The relationship between table student and project is defined by defining common attribute in both the tables. This can be done by including the primary key of any one table in the other table as non-key attribute called foreign key as shown. One-to-many association. There are two possibilities for binary one-to-many association. These are, number 1, if the relationship has an associative entity, then each entity class is converted into a table and common attribute is already defined. Consider the ER model as shown. The entity class employee is converted into employee table with columns employee number as primary key and name. The entity class skill is converted into skill table with column employee number and skill both as composite key. The common attribute employee number in both the tables is already included. The sample rows are shown as. Number 2. If the relationship has strong entities, then each entity class is to be converted into a table. The primary key of table, which is formed from entity class having cardinality 1, is to be included to the table, which is formed from entity class having many cardinality as foreign key. Consider the ER model as shown. The relationship place is a binary relationship as its degree is 2. The entity classes are customer with attributes customer number as primary key and name, order with attributes order number as primary key and amount. Dear learners, let us see how this conversion takes place. The entity class customer is converted into customer table with columns customer number as primary key and name. The entity class order is converted into order table with columns order number as primary key and amount. The relationship between these tables is formed by including the primary key of customer table, that is attribute customer number, to table order as foreign key. The sample rows are shown as. Dear learners, so far we have discussed two types of associations of binary relationship conversion into set of tables. Now we will discuss many-to-many relationship conversion. Here is the detail. There are two possibilities for existence of a binary many-to-many relationship. These are with associative entity, without associative entity. Let us discuss each one in detail. With associative entity. If there is binary relationship with an associative entity, then every entity class including associative entity is converted into a table. The attributes of each entity class becomes columns of corresponding table. Consider the ER model as shown. Let us examine how this model is converted into set of tables. The entity class student is converted into student table with column registration number as primary key and name. The entity class course is converted into course table with columns course code as primary key and title. The associative entity class register is converted into registration table with columns registration number and course code both as composite key. The sample rows are shown as without associative entity. If there is a binary many-to-many relationship without associative entity, then each entity class is converted into a table. Additionally, an additional table is also created. The primary key of each table created is included in the additional table as composite key. Consider the ER model as shown. Let us examine how this model is converted into tables. The entity class student is converted into student table. The attributes of entity class student are converted into columns of student table. The column registration number is selected as primary key. The entity class course is converted into course table. The attributes of entity class course are converted into columns of course table. The column course code is selected as primary key. An additional table registration is created. The primary key of student table, that is registration number, and primary key of course table, that is course code, are included as composite key. The sample rows of student table are shown as. The sample rows of course table are shown as. The sample rows of registration table are shown as. The binary many-to-many relationship may also have non-key attributes such as attribute, date of registration, as shown. The table formation process is same as discussed earlier as shown. The non-key attributes of the relationship are included in the additional table such as date of registration, in this case as shown. Unary relationship conversion. The entities with unary relationship are also converted into tables just like the entities with binary relationship. The common attribute, that is foreign key, is to be added such that it references the primary key value of the same table. Such type of foreign key is called recursive foreign key. Dear learners, let us discuss various possible cases of unary relationship. These are one-to-one association, one-to-many association, many-to-many association. Here is the detail of each case. One-to-one association. The entity class of unary relationship of the type 1-to-1 is converted into a table. The attributes of the entity class are converted into columns of the table. The primary key of the entity class is converted into primary key of the table. This primary key is added as recursive foreign key with a new name. Consider the unary relationship managed of the type 1-to-1 with an entity class employee as shown. The entity class employee is converted into employee table. The attributes of the employee number and name are converted into columns of the table. The primary key of the entity class employee is converted into primary key of the table employee. This primary key is added as recursive foreign key with a new name manager. The sample rows of employee table are shown as one-to-many association. The one-to-many unary relationship is converted into tables in the same manner as one-to-one unary relationship as discussed earlier. Many-to-many association. The entity class of unary relationship of the type many-to-many is converted into two tables. The attributes of the entity class are converted into columns of one table. The primary key of the entity class is converted into primary key of the table. An additional table is also created. The primary key of the table created from entity class is included in the additional table along with another column which is with the new name of the primary key of the same table. This additional table must have composite key. Consider the unary relationship managed of the type many-to-many with an entity class employee as shown. The entity class employee is converted into employee table. The attributes of the employee class, employee number and name are converted into columns of the table. The primary key of the entity class employee is converted into primary key of the table employee. An additional table manager is created. The columns include the primary key of employee table and an additional column manager. The columns employee number and manager forms the composite key. This primary key is added as a recursive foreign key with the new name manager. Super and subtype conversion. The super and subtype relationships are converted into tables as number 1. Convert supertype entity into a table. All the attributes of supertype become the column of that table. The key of supertype will be the key of resultant table. Number 2. Convert each subtype into separate table. The attributes of all subtypes will become the columns of respective tables. The key of supertype table will be included into all tables. Consider the super and subtype ER model as shown. Dear learners, let us examine how this model is converted into tables. Here is the detail. The supertype entity faculty member is converted into faculty table with columns employee code as primary key and name. The subtype regular is converted into regular table with columns employee code as primary key, designation and salary. Similarly, the subtype visiting is converted into visiting table with columns employee code as primary key, rate per hour and contract period. The sample rows of faculty table are shown as. The sample rows of regular table are shown as. The sample rows of visiting table are shown as. Dear learners, so far we learned how to construct tables. Now we will learn how these tables are normalized, which is the theme of this unit. Introduction. This unit focuses on the splitting of complex tables into simple meaningful tables. Objectives. The objectives of the unit are to understand the normalization process, why tables need normalization, functional dependencies in tables, first normal form, second normal form and third normal form, how tables are normalized up to third normal form. Introduction to normalization. Dear learners, as you know that a database is an integrated collection of data, the large tables need meaningful subdivision into smaller tables. These small tables are easy to administer and control for efficient processing and storage. The normalization is the process by which a table is splitted into smaller meaningful tables. Dear learners, here an important question arises. Why a table needs normalization? The splitting of a table is evaluated in terms of three anomalies. These are insert, update, delete. Let us now discuss each in more detail. Insert anomaly. It is the problem of adding new row in a table for one or other reason. For example, consider table course as shown. The analysis of the table course shows that it is a valid table as it satisfies all basic conditions such as the table has a primary key which ensures that each row is unique and each column is unique. Dear learners, though it is a valid table, but let us see what will happen if it is required to add a row in order to define a course with course code CS3441 entitled Computer Networks with the assumption that this course is not registered by any student. This can be done only if providing values of primary key attribute that are registration number and course code, but the value of registration number is missing as the course is not yet registered by any student. Thus, course data cannot be defined unless registered by a student. Therefore, the course table has insert anomaly. Update anomaly. It is the problem of updating a row in a table for one or other reason. For example, in the table course, if it is required to update the course title, database 1, then it needs multiple updates due to redundancy. Thus, the course table has the update anomaly. Delete anomaly. It is the problem of deleting a row or rows from a table for one or other reason. For example, in the table course, if it is required to delete the course registration of student with registration number R3 for course CS3413 data communication, this will result in the deletion of entire row and will also delete the course data CS3413 and data communication. Thus, the table course has the delete anomaly. Dear learners, a table with any of the anomaly discussed is considered to be a poor table. Therefore, such tables need some treatment. The normalization is a technique used to control these anomalies discussed earlier. Dear learners, there are two stages of normalization. These are simple normal forms, higher normal forms. Most of the business applications need simple normal forms. Therefore, only simple normal forms are discussed here. Dr. E. F. Codd proposes the simple normal forms. There are three stages of simple normal form. These are first normal form, second normal form, and third normal form. Let us discuss each in more detail. First normal form. A table is said to be in first normal form if there is no multi-valued attribute. For example, consider the table student as shown. The sample rows show that each student has one value of name and phone number. Dear learner, the table student is in the first normal form because there is no multi-valued attribute. Let us modify business rule for the table student as a student may have many phone numbers. The sample rows are shown as analyze the table carefully for validity. Do you think this is a valid table? Surely not, because it violates an important rule of database tables, that is, there must be primary key. The existence of multi-valued attribute phone prohibits the primary key definition. This problem is handled by two ways. These are eliminate the multi-valued attribute by defining composite key as shown. Now the table shown as is a valid database table as there is a composite key. But this method of eliminating multi-valued attribute is not effective and has a serious drawback that it introduces the update anomaly due to redundancy. For example, in the table as shown, the name of student, that is Arsalan, is stored redundantly. Let us discuss second solution of the stated problem. Extract multi-valued attributes from given table and place them in a separate table such that the newly created table must have a composite key. This composite key must have the primary key of original table as a part. This means that the original table, which is not in the first normal form, shall be decomposed into two tables, such that multi-valued attributes are placed in one table and single-valued attributes are placed in another table. Dear learners, a table with multi-valued attribute may also be converted into first normal form by replacing the multi-valued attribute with an atomic attribute for each value. For example, the table student with the multi-valued attribute phone as shown. It is converted into first normal form by replacing the multi-valued attribute with atomic attributes for a number of phone values as shown. This approach should be avoided for these reasons. If new phone number is required to be added for a given student, this may be done only by adding new column to the table. This brings structural changes in the table. Therefore, each time a new value is to be added, structural change of the table is required. It is not necessary that a given student must have defined number of phone numbers. Therefore, blank spaces may be stored against the phone number for which there is no value. This leads to storage wastage. Functional dependency. The functional dependency is the relationship between attributes of a table. It determines how the values of one attribute A determine the value of another attribute B in table T. Graphically, it is represented as shown. It is important to note that the attributes on either side of the arrow may be more than one as shown. The attributes at left side of the arrow are called determinant because it always determines the value of each attribute at right side of the arrow. For example, consider the table student as shown. Look carefully. The value of attribute name could be determined by knowing the value of attribute registration number. Similarly, knowing the registration number of a student, the value of attribute city could also be determined. This is shown graphically as. Dear learners, now it is time to discuss various types of functional dependency. These are partial dependency, full dependency, transitive dependency. In addition, there are other types also, which are beyond the scope of current discussion. Therefore, only stated dependencies are discussed here. Partial dependency. It is the dependency where non-key attributes are functionally dependent on any part of the composite key. For example, consider the table employee as shown. Dear learners, let us analyze the table. Knowing the value of key attribute employee ID, the value of non-key attribute name can be determined. Thus, the non-key attribute name is partially dependent on composite key. This dependency is represented graphically as shown. Similarly, knowing the value of key attribute software ID, the value of non-key attribute software title can be determined. Thus, the non-key attribute software title is partially dependent on composite key. This dependency is represented graphically as shown. Full dependency. It is the dependency where non-key attributes are functionally dependent on complete composite key. For example, consider the employee table once again and look carefully. The value of non-key attribute hours worked can be determined only if knowing the values of all key attributes, that are employee ID and software ID. Thus, the non-key attribute hours worked is fully functionally dependent on composite key. This dependency is represented graphically as shown. Transitive dependency. It is the dependency where non-key attributes become determinant of other non-key attributes. Dear learners, look at this table carefully. The value of non-key attribute date of completion could be determined by knowing the value of non-key attribute project ID. Thus, the non-key attribute project ID becomes determinant of another non-key attribute date completion. This is transitive dependency and is represented graphically as shown. Second normal form. A table is said to be in second normal form if it is in first normal form and there is no partial dependency. Dear learners, there are two possibilities for existence of partial dependency. Each one is treated in different way. These are along with full dependency, without full dependency. Let us discuss each in more detail. A table having partial dependency along with full dependency is decomposed as. Convert each partial dependency into a new table. The determinant of each partial dependency becomes the primary key attribute of corresponding table. The full dependency is converted into another table. Dear learners, look at the employee table. Do you think the table is in the first normal form? Yes, very good. The table is in the first normal form because there is no multi-valued attribute. Let us evaluate the table for various anomalies. Here is the analysis. New software cannot be added until an employee is assigned to it. Similarly, new employee cannot be added until software is not assigned to that employee. Thus, we are forced to stop adding rows, so the table has insert anomaly. Multiple updates of a software title are needed as it is redundantly stored. Similarly, Multiple updates of an employee name are also needed as it is redundantly stored. Thus, the table has update anomaly. By deleting the employee Fawad Rauf, the data of Visual Basic software is also deleted as there is single employee working with it. Thus, the table has delete anomaly. Dear learners, the table is in the first normal form, but still it has all anomalies. Let us find out the reason. Yes, there is a partial dependency along with full dependency. Now, let us find out the solution. The solution is that first, identify the partial and full dependencies as shown. Then, apply the decomposition rule as the partial dependency as shown is converted into employee table. The determinant of this partial dependency, that is attribute employee ID, becomes the primary key attribute of employee table. Similarly, the partial dependency as shown is converted into software table. The determinant of this partial dependency, that is attribute software ID, becomes the primary key attribute of software table. The full dependency as shown is converted into work table with composite key attributes that are employee ID and software ID. Dear learners, let us now compare the employee table before splitting as shown with the newly created tables, employee table as shown, software table as shown, and work table as shown. The new employee could be easily added in the newly created employee table, which is not possible without software in original employee table. The new software could be easily added in software table, which is not possible without an employee in original employee table. The software title update in software table does not need multiple updates as there is no redundancy, while need multiple updates in original employee table. Similarly, the employee name update in new employee table does not need multiple updates as there is no redundancy, while need multiple updates in original employee table. The employee deletion from new employee table has no effect on software table, while software data is deleted on deletion of an employee from original employee table. But an employee deletion from new employee table and software deletion from software table has effect on work table. This issue is controlled by applying integrity rules which are beyond the scope of current discussion. Dear learners, let us now discuss second possibility of existence of partial dependency, that is without full dependency. A table having partial dependency without full dependency is decomposed as each partial dependency is converted into a new table. The determinant of each partial dependency becomes the primary key attribute of corresponding table. The composite key attributes of original table are placed in another table with a composite key, which comprises the primary key attribute of each new table. Consider the employee table with an assumption that a given job may be assigned to only one employee, but an employee may be assigned many jobs, as shown. Dear learners, the table is in the first normal form because there is no multi-valued attribute. Let us evaluate the table for various anomalies. Here is the analysis. New job cannot be defined until not assigned to an employee. Similarly, new employee cannot be defined until a job is assigned to that employee. Thus, we are forced to stop adding rows. Thus, the table has insert anomaly. The name update of an employee need multiple updates as it is stored redundantly. Thus, the table has update anomaly. If it is required to delete the employee named Daniel Daud, this leads to the deletion of job J3 data also. Thus, the table has delete anomaly. Dear learners, the table is in the first normal form, but still has all anomalies. The only reason is the existence of partial dependency without full dependency. As discussed earlier, first identify the partial dependency as shown. Then apply the decomposition rule as the partial dependency is converted into a new employee table. The determinant of this partial dependency, that is attribute employee ID, becomes the primary key attribute of new employee table. Similarly, the partial dependency as shown converted into job table. The determinant of this partial dependency, that is attribute job ID, becomes the primary key attribute of job table. The composite key attributes of employee table before splitting, that are employee ID and job ID, are placed in employee job table as shown. Dear learners, let us now compare the original employee table before splitting as shown with newly created employee table as shown, job table as shown, and employee job table as shown. A new employee could be easily added in newly created employee table, which is not possible without job in original employee table. A new job could be easily added in job table, which is not possible without job in original employee table. An employee name update in new employee table does not need multiple updates as there is no redundancy, while need multiple updates in original employee table. Similarly, the update of job description in job table does not need multiple updates as there is no redundancy, while need multiple updates in original employee table. The employee deletion from newly created employee table has no effect on job table, while job data is deleted on deletion of an employee from original employee table. But the deletion of employee from new employee table and deletion of job from job table has effect on employee job table. This issue is controlled by applying integrity rules, which are beyond the scope of current discussion. Third normal form. A table is said to be in third normal form if it is in second normal form and there is no transitive dependency. Dear learners, it is now clear that if a 2NF table has any of the insert, update or delete anomaly, then there is transitive dependency. The table is refined to 3NF by separating each transitive dependency and convert it into new tables. The determinant of each transitive dependency becomes primary key attribute of corresponding table. There are two possibilities for existence of transitive dependency. These are where the determinant has single attribute, where the determinant has multi-attribute. Let us discuss each in more detail. Single determinant attribute. If a 2NF table has a transitive dependency where the determinant has a single attribute, then the transitive dependency is converted into a new table. Dear learners, the transitive dependency is not restricted to one. Thus, each transitive dependency is extracted from original table and converted into a new table. The determinant of each transitive dependency becomes the primary key attribute of corresponding table. Add the primary key of each table resulted from transitive dependency as foreign key in original table along with all remaining attributes. Consider the table employee once again. As shown, look carefully at the table. Is the table in the first normal form? Yes, the table is in the first normal form because there is no multi-valued attribute. Now analyze it for second normal form. It is very easy as there is no composite key. Therefore, there is no chance for existence of partial dependency. Thus, the table is in the second normal form. But let us evaluate the table for various anomalies. New project cannot be defined until an employee is not assigned to the project. Thus, the table has insert anomaly. The update of project completion date need multiple updates because it is stored redundantly. Thus, the table has update anomaly. The deletion of an employee may result the deletion of project data also if there is single employee in that project. Thus, the table has delete anomaly. Dear learners, the table is in the second normal form but still has all anomalies. The only reason is the existence of transitive dependency as shown. Now let us resolve these anomalies. This second normal form table needs decomposition as the transitive dependency as shown is converted into project table. The determinant of this transitive dependency, that is attribute project ID, becomes the primary key attribute of project table. Add this primary key to employee table as a foreign key, along with remaining attributes. Dear learners, let us now compare the employee table before splitting, as shown, with newly created employee table, as shown, and project table, as shown. New project could be easily added in table project, which is not possible without an employee in original employee table. The update of project completion date in table project does not need multiple updates, as there is no redundancy, while need multiple updates in original employee table. The deletion of employee from table employee has no effect on table project, while project data is deleted on deletion of an employee from original employee table. The deletion of project from table project has effect on table employee. This issue is controlled by applying integrity rules, which are beyond the scope of current discussion. Let us now discuss multi-attribute determinant in transitive dependency. Consider the table route as shown. It stores the distance in kilometers of different routes along with driver identification. Dear learners, the table is in the second normal form as there is no multi-valued attribute and no partial dependency, but still the table has these anomalies. New route cannot be defined until a driver is not assigned. Thus the table has insert anomaly. Deletion of driver data may result the deletion of route. Thus the table has delete anomaly. The reason of all these anomalies is the existence of transitive dependency, but this time the determinant is composed of multi-attributes that are origin and destination. The table route is to be refined to third normal form by adopting the same decomposition rule as discussed earlier. The transitive dependency, as shown, is converted into distance table. The determinant of this transitive dependency, that is attributes origin and destination, becomes the composite key attribute of distance table. Add this composite key to driver table as a foreign key along with remaining attributes. Dear learners, let us now compare the route table before splitting, as shown, with driver table, as shown, and distance table, as shown. The new route, that is origin and destination, could be easily added in distance table without driver information, which is not possible in route table. The deletion of a driver from table driver has no effect on table distance while route data is deleted. If driver data is deleted from route table, the deletion of route from distance table has effect on driver table. This issue is controlled by applying integrity rules, which are beyond the scope of current discussion.
Dear learners, so far we learned how the database tables are derived from entity relationship model and convert them into normalized form. Introduction. This unit focuses on how tables are organized into a detailed blueprint called logical design. Afterwards, how a logical design is converted into a physical design. Objectives. The objectives of the unit are to explain design objectives of database design, phases of database design, which includes requirements collection and analysis, conceptual database design, selection of database product, logical database design, physical database design. Introduction to database design process. Dear learners, the design is one of the most crucial phase of the information system development. The database design is implemented by a database product such as Oracle and MS Access. Therefore, it must be perfect and technically sound. Thus, a poor database design will lead to a poor system development. Dear learners, let us define database design process. It is the designing of logical and physical structure of database tables to accommodate the information needs of users in an organization. Design objectives. The major goals of database design are: satisfy the information needs of the specified users and applications, provide an easy-to-understand structuring of the information, support processing requirements and any performance objectives such as response time, processing time, and storage space. Design phase. Dear learners, the database design process is a composition of 5 sequential phases. These are: requirements collection and analysis, conceptual database design, selection of database product, logical database design, physical database design. Requirements collection and analysis. The requirements collection and analysis is the originating point of a database design. One must know and carefully analyze the requirements collection and analysis for effective database design. The major activities during this phase are: the identification of major application areas and user groups that will use the database system under study. Existing documents concerning the application are studied and analyzed. Study the present operating environment, if any. The requirements analysis is carried out by a team of experts with the active participation of customer and other stakeholder. The stakeholder are those who have significant impact on system under study. Therefore, joint application design methodology is used for refining initial system requirements. The requirement collection and analysis phase is normally a time-consuming but is crucial to the success of the information system. Conceptual database design. The goal of conceptual database design phase is to produce a conceptual schema for the database that is independent of a specific DBMS. It involves 2 parallel activities. These are conceptual schema design, transaction design. Let us discuss each in more detail. Conceptual schema design. It examines the data requirements resulting from requirements collection and analysis. It produces a conceptual schema. The conceptual schema design is a complete understanding of the database structure, semantic interrelationships, and constraints. Dear learners, after a detailed discussion on conceptual design schema, now it is time to discuss the transaction design activity of conceptual database design. Transaction design. The purpose of transaction design is to design the characteristics of known database transactions in a DBMS independent way. Usually, only some of the database transactions are known at design time, and after the database system is implemented, new transactions are continuously identified and implemented. However, the most important transactions are often known in advance of system implementation and should be specified at an early stage. Transactions usually can be grouped into 3 categories. Retrieval transactions, which are used to retrieve data for display on a screen or for production of a report. Update transactions, which are used to enter new data or to modify existing data in the database. Mixed transactions, which are used for more complex applications that do some retrieval and some update. Selection of database product. The selection of a database product for database development depends upon two important factors: technical, non-technical. Technical. The technical factors are concerned with the suitability of DBMS product with reference of technical issues such as storage structures, access paths support, interface, architectural options. Non-technical. The non-technical factors are concerned with the suitability of DBMS product with reference of non-technical issues such as finance, support of the supplier. However, there are economic and organizational factors also that affect the choice of DBMS. These are economic factors, organizational factors. Economic factors. The economic factors are software acquisition cost. The software acquisition cost includes selected version of DBMS product, other software needed. Maintenance cost. This is the recurring cost of receiving standard maintenance from vendor and for keeping the DBMS version up to date. Hardware. The hardware cost includes new hardware needed such as additional memory, computers, disk drives. Database creation and conversion cost. This is the cost of either creating the database system from scratch or converting an existing system to the new DBMS software. This cost is hard to project and is often underestimated. Personnel cost. Acquisition of DBMS software for the first time by an organization is often accompanied by a reorganization of the data processing department. Positions of DBA and staff exist in most companies that have adopted DBMSs. Training cost. The DBMSs are often complex systems and the related personnel must often be trained to use and program the DBMS. Training is required at all levels including programming, application development, and database administration. Operating cost. The cost of continued operation of the database system is typically not worked into an evaluation of alternatives because it is incurred regardless of the DBMS selected. Organizational factors. The organizational factors are organization-wide adoption of a certain philosophy. This is often a dominant factor affecting the acceptability of a certain data, a certain vendor, or a certain development methodology and tools. Familiarity of personnel with the system. If the programming personnel within the organization are familiar with a particular DBMS, it may be favored to reduce training cost and learning time. Availability of vendor services. The availability of vendor assistance in solving problems with the system is important since moving from a non-DBMS to a DBMS environment is generally a major undertaking and requires much vendor assistance at the start. DBMS portability. Many commercial database management systems now have versions that run on many hardware and software configurations. The need of applications for backup, recovery, performance, integrity and security must also be considered. Many database management systems are currently being designed as total solutions to the information processing and information resource management needs within organizations. Logical database design. The logical database design is the process of designing tables and their relationships. This database design is free of any DBMS product and could be easily implemented on any selected database product in lateral stage of design. The logical database design can be achieved by designing tables directly from the detailed description of the system under study without using any modeling tool such as entity relationship model. But it is strongly recommended that entity relationship model shall be used as structured analytical tool which is easily converted into logical database design. Physical database design. Physical database design is the process of choosing specific storage structures and access paths for the database files to achieve good performance for the various database applications. Each DBMS offers a variety of options for file organization and access paths. These usually include various types of indexing, clustering of related records on disk blocks, linking related records via pointers, and various types of hashing. Once a specific DBMS is chosen, the physical database design process is restricted to choosing the most appropriate structures for the database files from among the options offered by that DBMS. These criteria are often used to guide the choice of physical database design options. Response time. This is the elapsed time between submitting a database transaction for execution and receiving a response. Response time is also influenced by factors not under DBMS control, such as system load, operating system scheduling, or communication delays. Space utilization. This is the amount of storage space used by the database files and their access path structures on disk, including indexes and other access paths. Transaction throughput. This is the average number of transactions that can be processed per minute. Transaction throughput must be measured under peak conditions on the system. Performance depends on record size and number of records in the file. Hence, we must estimate these parameters for each file. Estimates of file growth either in the record size because of new attributes or in the number of records should also be taken into account during physical database design. Dear learners, so far we learned the database foundation, analysis and design. Now it is time to implement the database design by using a tool. The Oracle is used for implementation. However, there are other tools also available such as MS Access. Introduction. This unit gives knowledge of hands-on experience to use SQL. It focuses on the creation, modification, deletion and manipulation of tables. Objectives. The objectives of the unit are to understand how to create tables, alter the tables, delete the tables, insert rows into a table, manipulate simple queries, use built-in functions, manage multiple tables. SQL Introduction. SQL is the abbreviation of Structured Query Language. It is pronounced as SQL or SQL. It has become a standard language for creating and querying the relational database. The users can manipulate database tables with little experience by applying simple commands. SQL command modes. The SQL commands are implemented on mainframe computers, client-server environment, or personal computers. There are two modes of implementation, which are embedded. The SQL commands are placed inside the host program and are executed along with it. Interact. The SQL commands are placed and executed on SQL prompt directly. SQL users. The database administrator may define many SQL users just like a network manager defines the network users. Every user has its own username and password assigned by the database administrator. The SQL provides two default generic users. DBA, the username is System and password is Manager. Generic user, the username is Scott and password is Tiger. However, the SQL user on PC may create new DBA, then may create many users. SQL data types. Dear learners, let us now discuss various data types that SQL supports. These are character. CHAR is the abbreviation of character data type. The character values consist of upper or lower case letters, numbers, or special characters such as plus, minus, dollar, and many more. The maximum length is 255 characters. Here is the general form. The general form starts with reserved word CHAR, followed by required length enclosed in parentheses. Number. The number data type values consist of digits from 0 to 9 with an optional prefix plus or minus sign or a decimal point. 40 digits is the maximum width of a value. The decimal point, plus or minus, if any, are not counted as digits. The number data type takes two forms. Integer. The integer number data type consists of integer numbers with optional plus or minus sign. Here is the general form. The general form starts with a reserved word number followed by required length enclosed in parentheses. Real. The real number data type consists of real numbers. Here is the general form. The general form starts with a reserved word number followed by required length. The required length consists of integer and real part separated by comma and enclosed in parentheses. Date. The date data type stores values from January 1st, 4712 BC to December 31st, 4712 AD. The date data type has fixed length and is not required to be defined. The date data type takes many forms, but the default form is as shown. Here is the general form. SQL commands. Dear learners, now it is time to discuss SQL commands, which are grouped as Data Definition Language, Data Manipulation Language, Data Control Language. The data definition language is used to define the table, alter the table, drop or delete the table, establish certain constraints on the table. The data manipulation language is used to mainly querying the table, updating the table, inserting rows into the table. The data control language is used to maintain security of table, administration of privileges on tables. Let us now discuss each in more detail. Data definition language. The data definition language commands include create table, alter table, insert. Here is the detail of each. Create table command. The purpose of create table command is to create a new table. The general form is shown as. The general form starts with the reserved word create table, followed by table name, followed by list of columns separated by comma and enclosed in parentheses. Let us see an example that demonstrates how to create a table. This command creates a table student. Alter table command. The purpose of alter table command is to modify the structure of an existing table. There are two types of modifications. These are add new column to a table, increase width of an existing column, add new column. The general form of add new column to an existing table is shown as. The general form starts with the reserved word alter table, followed by a table name, followed by another reserved word add, followed by list of columns to be added, which are enclosed in parentheses and separated by comma. Here is the example to add column city to student table. Increase width of an existing column. The general form of alter table command to increase width of an existing column starts with the reserved word alter table, followed by a table name, followed by another reserved word modify, followed by list of columns with increased width, which are enclosed in parentheses and separated by comma. Here is the example to increase the width of column city to 25 characters in the table student. Dear learners, let us now discuss insert command. The purpose of insert command is to insert rows into a table. There are two forms insert values for all columns. Insert values for selected columns. Let us discuss each in detail. Insert values for all columns. If it is required to insert values for all columns for a given row in a table, then the general form of insert command starts with the reserved word insert into, followed by table name, followed by another reserved word values, followed by list of values separated by comma and enclosed in parentheses. Dear learners, it is important to note that the values specified must be in the same order as the order of the columns in the table. Now it is time to learn how to insert a row into the table. Here is the example to insert a row into the table Student. Insert values for selected columns. If it is required to insert values for selected columns for a given row, then the general form of insert command starts with a reserved word insert into, followed by table name, followed by list of selected columns separated by comma and enclosed in parentheses, followed by another reserved word values, followed by list of values which are separated by comma and enclosed in parentheses. Inserting null values. The null value means no value. It is important to note that 0 and blank space is not a null value. The null value may be assigned to any column except the primary key column or any column defined as not null. Dear learners, consider the table Student as shown. The command will insert a null to column City. Inserting date values. The date data type value is enclosed in single quotation marks, just like character data type value as shown. There are many date formats, but the default format is. Consider the table Student. The command will insert a date value to column Date of birth. Updating rows. Dear learners, the change in already existed data is a frequent practice for various reasons. This can be accomplished by update command. The general form starts with the reserved word update, followed by table name, followed by another reserved word set, followed by list of columns, and optionally at the end follows where condition. The column list contains columns separated by comma and each with new value. Dear learners, consider the table Student. Let us discuss some queries that update rows. The query is, update program of student from BS to MS whose registration number is equal to 2. The select command applied is. The output of this command is. It is important to note that If it is required to update single row, then where condition shall be applied on primary key or alternate key. If it is required to update many rows, then where condition shall be applied on secondary key. If it is required to update all rows, then where condition must not be specified. Deleting rows. Dear learners, the removal of unwanted existing data is a frequent practice for various reasons. This can be accomplished by delete command. The general form starts with reserved word delete from, followed by table name, followed by optionally where condition. Dear learners, consider the table student. Let us discuss some queries that delete rows. Student whose registration number is 2. Command applied. The output of this command is: Dear learners, multiple rows may be deleted as shown. Querying the table. Dear learners, as you know that data is stored for a reason, that it must be available when needed. Thus, a query is generated for getting quick and ad hoc requirements from database tables. The DML commands are used to manipulate the database, which is discussed in the subsequent section. Display all columns. Dear learners, let us learn how rows of a table are displayed. The select command is used to display values of all columns in a table. The general form starts with a reserved word select, followed by list of columns to be displayed, which are separated by comma, followed by another reserved word from, followed by the table name. Dear learners, it is important to note that the columns specified in the list not necessarily be in the order of columns as defined in the table creation. Here is the example to demonstrate how to display all columns for all rows. This command will display all rows for all columns. Dear learners, if list of columns is very long and all are required to be displayed, there is an easy way to replace the column list with an asterisk. It is important to note that values of columns will be displayed exactly in the order as defined during table creation. The output of this command preventing redundant display of a column. Dear learners, first consider the table student with the rows as shown. If it is required to display list of cities, the command applied is the output resulted. The careful analysis of the output shows redundant information such as city Islamabad and Lahore is displayed twice. This problem is solved by adding distinct to the select command. the output resulted is shown as. Dear learners, this output does not have redundant display. Displaying selected rows. Dear learners, so far we learned to display all rows from a table, but very often it is common requirement to display selected rows. The where clause is added to select command in order to display selected rows. The general form starts with reserved word where followed by condition. The where condition is used to specify the search criteria, and it takes two forms: simple conditions and complex conditions. Let us discuss each in detail. Simple conditions. The simple conditions are those where only one condition is specified in the select command. The general form is. The column name is the name of column and operator is the relational operator which actually compares two given sets of values that are value of the column for current row and value of search criteria. The table as shown lists 6 relational operators used with where in select command. Dear learners, consider the table student for given rows. Let us discuss some queries using simple conditions. The query is: display the list of students whose registration number is greater than 3. The select command applied is. The output of this command is. Let us see another query that display record of student whose registration number is equal to 2. The select command applied is. The output of this command is. Let us see another query that is display the list of students belonging to city Lahore. The select command applied is. The output of this command is. Dear learners, it is important to note that the string values comparison is exact matching. That is, this value of student name Danial is different from the value Danial. Let us see another query that is display the list of students whose birth date is less than January 1st, 1980. The select command applied is. The output of this command is. It is important to note that the date values are written. Let us see another query that is display the list of students of all programs except MS. The select command applied is. The output of this command is. Dear learners, let us now discuss complex conditions. The complex conditions are those conditions where multiple conditions are specified in a select command. The general form is. The logical operator in the general form is the operator that joins multiple conditions in single expression. There are three such logical operators. These are: the AND operator results in true if both the conditions are true. The OR operator results in true if either of the condition is true. The NOT logical operator negates the value of complex condition. Dear learners, many logical operators may be used in single expression, but the parentheses are cleared first, then AND operators are evaluated from left to right, then OR are evaluated first from left to right, the NOT operator is evaluated finally. Dear learners, consider the table student. Once again, let us discuss some queries using complex conditions. The query is: display the list of students who are registered in MS program and belong to city Lahore. The select command applied is. The output of this command is. Let us see another query, that is, display the list of students who are registered in MS program or belong to city Lahore. The select command applied is. The output of this command is. Another query, that is, display the list of students who do not belong to city Lahore or Peshawar. The select command applied is. The output of this command is. Display the list of students who do not belong to city Lahore or Peshawar and belong to city Karachi. The select command applied is. The output of this command. Display rows in range. Dear learners, so far we learned to display rows either all or selected. But very often it is required to display selected rows in a specified range. The AND logical operator and a special operator between are used to display rows in particular range. Dear learners, consider the table student. Let us discuss some queries that display rows in a range. The query is: display the list of students whose GPA is between 3 and 3.8. The select command applied is. The output of this command is. The between operator is a special operator used as alternative to AND logical operator for displaying rows in a range. The output of this command is. Dear learners, the between operator can be negated with using not to display only rows outside the range. Let us see another query, that is, display the list of students whose GPA is less than 3 and greater than 3.8. The select command applied is the output of this command is displaying rows from a list. The OR logical operator and a special operator in are used to display rows from a given list not in a range. Dear learners, consider the table student. Let us discuss some queries that display rows from a list not in a range. The query is, display the list of students whose GPA is either 2 or 3 or 2.5 or 3.8. The select command applied is shown as. The output of this command is shown as. The in operator is a special operator used as alternative to OR logical operator for displaying rows from the list not in a range. The output of this command is shown as. Dear learners, the in operator can be negated with using not to display only rows outside the range. Let us see another query, that is, display the list of students whose GPA is not equal to 2 or 3 or 2.5 or 3.8. The select command applied is. The output of this command is shown as. Displaying rows matching a character pattern. The like is a special operator used to select rows that partially match a pattern of characters. The like operator recognizes two special characters. % means any sequence of characters. Underscore means single character. Dear learners, consider the table student. Consider the query. Display the name of students whose name begins with D, whatever the rest of characters are. The select command applied is. The output of this command is shown as. Let us see another query, that is, display the name of students whose name begins with D or A, whatever the rest of characters are. The select command applied is. The output of this command is. Dear learners, suppose we cannot remember whether an employee Daud spells his name D-A-U-D or D-A-W-O-O-D or D-A-O-D. Use an underscore within the character value to indicate one character. Display rows in order. Dear learners, so far we learned queries that display all rows are selected in same order as they are fetched, but very often it is required to control the order of display. This can be done by adding the order by clause to a select command. The general form is shown as. The general form starts with reserved word select followed by list of columns, followed by another reserved word from, followed by table name, followed by another reserved word order by, followed by type of order that is either ascending or descending. The default order is ascending and does not need to be specified. The order by clause, when present, must be the last clause in a select command. When order by columns that contain null values, the null entries are always displayed first, regardless of choosing ascending or descending order. Dear learners, consider the table students. Let us discuss some queries that display rows in order. The query is, display records of students alphabetically arranged in ascending order by name. The select command applied is. The output of this command is. Dear learners, the order by may be used with many columns. SQL functions. Dear learners, so far using SQL we learnt how to display all rows, how to display selected rows either in a range or from a list, how to display these rows in an order, how to update rows, how to delete rows. But very often it is common requirement to manipulate data in the database tables. The SQL provides built-in functions in addition to other processing capabilities. The SQL provides these built-in functions. Character string manipulation like rtrim, ltrim, upper, lower. Numeric calculations like average, count, maximum, minimum, sum. Date calculation like sysdate. Convert data from one data type to another like character to row ID to character. The numeric functions are discussed in more detail in the subsequent section. Numeric functions. The numeric functions are such functions which are used for manipulation of numeric data type columns. There are two types of numeric functions. These are individual and group. Let us discuss each in more detail. Individual numeric functions. The individual numeric functions return a value for each row selected. Dear learners, consider the table students. Let us discuss a query using individual numeric function. The query is, display the GPA of each student in integer form. The select command that uses individual numeric function round applied is. The output of this command is numeric functions. The group numeric functions are used to get summarized information from group of rows selected. For example, the average marks obtained by students in a given course. the highest marks obtained by students in a given course, the lowest marks obtained by students in a given course. Dear learners, the group numeric functions are used in two ways: by summarizing one group, by summarizing many groups. By summarizing one group, the rows are selected to form only one group to get one result, such as average marks obtained by students in a given course. The select command that uses group numeric function average applied is the output of this command is Dear learners, here are few commonly used group numeric functions. Count. It is used to count number of non-null rows. The select command that uses function count is the output of this command is maximum. It is used to display maximum value in a column. The select command that uses function max is the output of this command It is used to display minimum value in a column. The select command that uses function minimum is the output of this command is It is used to display sum of a column. The select command that uses function sum is the output of this command is shown as by summarizing many groups. The rows are selected to form many subgroups. It provides the result of each subgroup as well as entire group result. For example, there are 10 departments in an organization with many employees in each department. If it is required to find out the total salary of each department, it is unusual to use sum function 10 times used for 10 departments. This could be done by using group by clause, which actually divides the given table into groups of rows. The general form starts with reserved word select, followed by a column on which subgroups are required, followed by comma, followed by a group function, followed by another column on which group function is to be applied, followed by optionally where condition, and at the end another reserved word group by, followed by a column on which subgroups are required. Dear learners, look at the table employee. Let us see some queries that use group functions by summarizing many groups. Here is the query of each department. The select command that uses function sum, the output of this command is the select command that uses function average is the output of this command is Dear learners, the group by clause is also used to form groups within a group, such as display total salary of each department designation-wise. Thus, two columns are required in this example, that are department, which forms outer group, designation, which forms inner group based on designation in each department. The select command that uses function sum is the output of this command is group selection. Dear learners, so far we used where clause for selection among the given rows. But very often it is required to select groups among given set of groups. The having clause is used for such purpose. For example, consider the query needed in table employee. Display total salary of each department where the number of employees are more than 5. The select command that uses having, the output of this command is managing multiple tables. Dear learners, so far we learnt working with a single table, but very often it is required to work with many tables having parent-child relationship. Consider these tables for all subsequent discussion as shown. Look at the table registration. It has two foreign keys that are registration number and course code. Dear learners, let us first learn how a foreign key is defined. There are two ways to define a foreign key in a table. These are during creation of the table, after creation of the table. Let us discuss each in more detail. During creation of the table, the foreign key can be defined during the creation of table. The general form is shown as. The general form starts with reserved word create table followed by table name followed by list of columns enclosed in parentheses followed by another reserved word add foreign key followed by foreign key attribute enclosed in parentheses followed by another reserved word references followed by table name which is referred followed by primary key attribute enclosed in parentheses. The create table command that defines foreign key is after creation of the table. The foreign key can also be defined after the creation of table. The general form is shown as. The general form starts with reserved word alter table followed by table name followed by another reserved word add foreign key followed by foreign key attribute enclosed in parentheses followed by another reserved word references followed by table name which is referred followed by primary key attribute enclosed in parentheses. The alter table command that adds a foreign key is shown as. Dear learners, the definition of foreign keys automatically enforce the referential integrity rules which are beyond the scope of current discussion. Manipulation of multiple tables. So far we learned to manipulate rows in a single table, but very often it is required to join rows of one table with rows of another table. For example, consider student, course, and registration tables for a query shown as display student name with all course titles registered. The select command that uses foreign key is shown as. The output of this command is shown as.
Dear learners, so far we learned to manipulate the data tables by using SQL commands. Now it is time to learn about building forms using Oracle Form Builder. Introduction. This unit is based on Developer 2000 forms. It introduces the basic concept of forms used for form designing. It focuses on architecture of an Oracle form. Objectives. The objectives of the unit are to explain description of various components of an Oracle form, various properties of window, and layout editor. Introduction to form. Dear learners, the Oracle Form Designer is a graphical tool which helps to generate sophisticated forms quickly. This tool allows designing forms used to capture and validate data with minimum code. Form components. The Oracle Form components comprise these components as shown: Form Designer, Form Generator, and Run Form. Let us discuss each one. The Form Designer is the component used by programmers to create a form. It allows user to design the layout of data entry screens and write code that may be required for data manipulation and validation. The Form Generator component is required to compile the file created in Form Designer and creates an executable binary file. The Run Form component is used to run the compiled code created by Form Generator. Application development in Oracle Forms. Any application being developed using Oracle Form contains a combination of these components: Form Module, Menu Module, PL/SQL Library, and Object Library. The Form Module is simply a collection of objects such as windows, blocks, canvas items, and event-based PL/SQL code blocks called triggers. The Menu Module is a collection of objects such as menu items, submenu items, and triggers. The PL/SQL Library is a collection of PL/SQL program units whose code can be referenced and called from other modules. The Object Library is a collection of objects related to form which can be used in form development. Form Module. Dear learners, let us now discuss the Form Module in detail. The Form Module consists of these components: block, items, canvas views, windows, and PL/SQL code. Now let us discuss these one by one. Block. A block is a container that holds a related group of objects such as text items, lists, and buttons. Blocks do not have a physical representation. Rather, only the items contained in a block are visible in the application interface. However, like other objects, blocks have properties and can be created, copied, and modified. Blocks provide a mechanism for grouping related items into a functional unit for storing, displaying, and manipulating records. Just as tables in the database consist of related columns and rows, blocks contain related items that display data. There is no practical limit to the number of blocks that can be defined in a form, but a form must have at least one block. Types of blocks. Dear learners, there are three classifications of blocks: data and control blocks, master and detail blocks, single record and multi-record. Data control blocks. Data block. The data blocks are associated with data, that is table columns within a database. By default, the association between a data block database allows operators to automatically query, update, insert and delete rows within a database. Control block. The control block is not associated with the database tables, rather has control items. The control item may be an item to initiate an action or display item or input item. There are 3 control items. These are 2 input items and a display item. The button Add initiates add action. Master detail blocks. The master block displays a master record associated with detail records, while a detail block displays detail records associated with a master record displayed in a master block. For example, record may be defined in master block and all dependence records may be defined in the detail block. Single record, multi-record. The single record block displays single record at runtime, while multi-record displays multiple records. Items. Items are actual objects contained in blocks. Dear learners, the items contained in a data block are called control items. Similarly, the items contained in data block are called data items. The control items and data items both can be placed in a data block, but usually this is not recommended. The control block as shown has 2 control items. Canvas views. A canvas is a surface inside a window container. The interface items are placed and the end users interact with them when they run the form. By default, any canvas created at runtime is assigned to the window named Window 1. To explicitly associate a canvas to a specific window, sets the canvas window property accordingly. Dear learners, let us now discuss various types of canvas views. The type determines how the canvas is displayed in the window to which it is assigned and determines which properties make sense for the canvas. The various types are content, staked, vertical toolbar canvas, horizontal toolbar canvas, and tab canvas. Let us discuss briefly each. Content. The content canvas. It is the default type, which specifies that the canvas occupies entire content area of the window to which it is assigned. Most canvases are of the type content. Staked. The staked canvas. It specifies that the canvas is displayed in its window at the same time as the window's content canvas. Staked views are usually displayed programmatically and overlay some portion of the content view displayed in the same window. Vertical toolbar canvas. It specifies that the canvas be displayed as a vertical toolbar under the menu bar of the window. The iconic buttons, pop lists, and other items on the toolbar may be defined if desired. Horizontal toolbar canvas. It specifies that the canvas be displayed as a horizontal toolbar at the left side of the window to which it is assigned. Tab canvas. The tab canvas, it is composed of one or more tab pages, which allows us to group and display a large amount of related information on a single dynamic canvas object. Like staked canvases, tab canvases are displayed on top of a content canvas. It occupies less space to save as compared to other canvases. Window. Dear learners, window is the next component of form module under discussion. The window limits the boundary of canvas views. However, The size of window can be increased or decreased, which automatically increases or decreases canvas view. Window is basically a container that is used to contain the canvas objects. Like other objects, window has its own properties. User can adjust these properties by using Properties window. PL/SQL code. The PL/SQL code is the last component of Form module. Dear learners, Oracle Form Builder provides PL/SQL editor interface called Trigger for the entering and compiling code objects. The code objects include event triggers, subprograms, menu item commands, menu startup code, and packages. Dear learners, after learning Form module, let us learn what is a trigger. The trigger is an object that contains block of code. Every trigger object has a name and contains one or more PL/SQL statements. Dear learners, Form Builder provides different triggers based on various events like when key pressed, when button pressed, when validate item, and many more. Look at this trigger. It saves records when save button is pressed. Object Navigator. The Object Navigator provides a hierarchical display of the objects in all open modules. Objects are grouped under the appropriate node. Dear learners, the top-level nodes in the Object Navigator include forms, menus, libraries, object libraries, built-in packages, and database objects. All other nodes and the objects they contain are intended to indicate that they belong to these higher-level nodes. Look at the Object Navigator. The objects and nodes are displayed with the plus or minus symbol to indicate whether they are currently expanded or collapsed. A gray plus is displayed for a node that does not yet contain lower-level objects. A round bullet is displayed in front of an atomic object that cannot contain any lower-level objects. Each object in the Object Navigator is displayed with an icon that indicates its type. For some objects, double-clicking the icon invokes an editor appropriate to that type of object. For example, double-clicking the object icon for a canvas invokes the layout editor. Dear learners, let us now discuss some operations performed by Object Navigator. Expand and collapse entries to locate objects quickly, as shown. Select objects, as shown. Create and delete objects, as shown. Copy and move objects within and between modules, as shown. Switch between views to display the objects to work, as shown. Locate objects quickly by searching with fast search, as shown. Quickly display the code associated with objects such as triggers and program units, as shown. Dear learners, in addition, commands may be selected in the Object Navigator from menu and toolbar. The toolbar provides quick access to commands. Click once on the icon for the command to execute. Property window. Dear learners, the property window is an easy way to customize any Form Builder object being created according to predefined properties. It is recommended to use comments property to add comments about the object for future reference. Layout Editor. Dear learners, the Layout Editor is a graphical design facility for creating and arranging interface items and graphic objects in a form. Let us now discuss the architecture of a layout editor. The title bar displays context information such as name of the current form, name of the canvas being edited, and name of current block. The canvas is the workplace to place various items being used in the form. Layout Editor permits working with only one canvas at any given instance of time. The horizontal and vertical rulers at the top and left side of the workspace provide a reference for sizing and arranging objects in the Layout Editor. The grid defined helps to position the objects within workspace.
Dear learners, in the previous unit, we learned about various components of an oracle form. Now, it is time to learn how these components are designed and developed. Introduction. This unit focuses on the development of forms by using Oracle Form Builder. Objectives. The objectives of the unit are to explain use of wizard for form designing, customizing a form, create various form items such as buttons, checkboxes, display items, list items, radio groups, text items, and list of values. Introduction to Developer 2000 Form Builder. The Developer 2000 Form Builder is an effective and professional way to design sophisticated forms. It is only one component of Developer 2000. The other components are Report Builder, Graphics Builder, and others. Introduction to Wizard. A wizard is a user-friendly series of steps used to design and develop forms. It is normally used by a beginner developer. Dear learners, follow these steps to load Developer 2000 Form Builder. After completing these steps, series of wizards will appear that will guide you to develop form. Look at the first wizard that appears with two group options, Designing and Learning. Let us discuss each in more detail. Designing. The designing option is used to design and develop forms. It further contains 4 options. These are building a new form using wizard. It is used to generate a new form using wizard through a series of wizards in an easy way. Build a new form manually. It is used to generate a new form manually using the Object Navigator. Dear learners, recall, Object Navigator is a hierarchical browsing and editing interface that enables to locate, manipulate, and design applications easily and quickly. Open an existing form. It is used to open an existing form, build a form based on template. It is used to generate a new form by choosing predefined templates according to requirements. Learning. It is used to learn Developer 2000 through help files. Dear learners, let us now learn how to develop a form using Wizard for the table Student. Load the Developer 2000 Form Builder application. Select Designing option. A welcome window appears. Click on Next. A window appears. It has 2 options. Select the option Table or View. Upon selection of Table or View, the next window appears asking for database table connectivity. Enter valid username and password. Upon providing valid username and password, the column list of the specified database table is displayed for selection. Select the columns needed in the form being designed. Next, Congratulations window appears. It contains 2 options. Let us discuss each. The first option further selects the canvas to be used. The second option does not provide access to canvas selection. However, at runtime, the default canvas is assigned, which enable the columns to appear in the form at runtime. Dear learners, let us proceed further with the first option of Congratulations window. Next, Canvas selection window appears. The canvas being used may be named and provides a canvas type selection that are content, stack, tab, vertical toolbar canvas, and horizontal toolbar canvas. Dear learners, next layout wizard appears with a series of windows. It deals with how the column selected previously will appear on form being developed at runtime. The first window that appears, it contains two windows. The left window contains columns available from the table. Dear learners, all these columns are not necessarily appearing in the form being developed at runtime. Thus, it becomes mandatory to make selection among columns displayed in the left window that are likely to appear in the form being developed at runtime. The selected columns for appearing in the form are shown in the right window. Next, column type window appears. It contains two options. Let us discuss each. The first option, that is form, is used for display of a single record in the form at runtime. The second option, that is tabular, is used for display of many records in the form at runtime. The next window appears. It sets attributes to either of the options selected in the previous wizard, such as frame name, number of records display, distance between records, and scroll bar. Next, the last window appears. It shows the end of form design being developed. Dear learners, pressing the Finish button leads to Object Navigator. It provides many facilities to work further, if needed, on the form designed through Wizard, such as use Layout Editor to set layout of various other form Customizing a form. Dear learners, so far we learned how to develop a form through Wizard using an Oracle Form Builder. This method is used commonly by beginners. Now we will learn to develop a form manually. This Item defining. Dear learners, we learned how to develop a form either using wizard or manual method. We also learned to add few items like text items and buttons to forms. Now we will learn how to define various items. These are push buttons, checkboxes, display items, list items, radio groups, text items, and list of values. Let us discuss each in more detail. Push button. Dear learners, we learned simply to add push buttons to a form without knowing it. Now it is time to learn more about push button. It is defined as: push buttons are interface items selected by end users to initiate actions. The form builder supports two types of button styles: text style, iconic style. The text style button is displayed as a rectangle with a text label inside. The text label describes the button's action. The iconic buttons are displayed as graphic icons without text labels, creating a push button. Let us learn how to create a push button from Object Navigator. Click the plus icon beside the desired block node. The form builder expands the block node and displays its sub-nodes. Click the Items node. Click the Create button in the toolbar. A new item with a default name is inserted under the Items node. Double-click the object icon beside the new item to display the property palette. Set the desired properties. Checkbox. Dear learners, the checkbox provides list of few options. It is important to note that many or all options are allowed for selection. It is displayed as a small square box with a text label to the right. The display state of a checkbox is always either checked or unchecked, but the default display status is checked. The state of a checkbox is toggled by clicking it. It can also be toggled by navigating to the checkbox and pressing Select. Dear learners, let us learn how to create a checkbox in the form. In the Object Navigator, click the plus icon beside the desired block node. The form builder expands the block node and displays its sub-nodes. Click the Items node. Click plus button in the toolbar. A new item with a default name is inserted under the Items node. Double-click the object icon next to the newly created item to invoke the property palette. Set the desired properties. Dear learners, it is important to note that the values must not be longer than the number of characters specified in the maximum length property. Display items. Dear learners, display items are similar to text items, with the exception that display items only display fetched or calculated values. It is important to note that the display items cannot be edited. Multi-line display items do not automatically wrap text. Dear learners, let us now learn how to create a display item in the form. In the Object Navigator, click the plus icon beside the desired block node. The Form Builder expands the block node and displays its subnodes. Click the Items node. Click the plus button in the toolbar. A new item with a default name is inserted under the Items node. Double-click the object icon next to the newly created item to invoke the property palette. Set the desired properties. Radio button. Dear learners, the radio button is a list of few options provided for selection of only one. It is important to note that if the selection of an option is changed, the new selection automatically deselects the previous selection. If selection of more than one options are required with the radio button, then the listed options are grouped, called radio groups. It is further to note that only one option can be selected from each group, and a group must contain minimum 2 radio options. Dear learners, let us now learn how to create radio button in forms. In the Object Navigator, click the plus icon beside the desired block node. The Form Builder expands the block node and displays its subnodes. Click the Items node. Click the plus button in the toolbar. A new item with a default name is inserted under the Items node. Double-click the object icon next to the newly created item to invoke the property palette. Set the desired properties. Dear learners, it is important to note that the radio button value must not be longer than the number of characters specified in the maximum length property. Dear learners, let us now learn how radio groups with radio buttons are created. The radio button procedure is same as discussed earlier. The radio group formation is done in the property palette. Text items. Dear learners, a text item is an interface control in horizontal rectangle box that displays and allows editing of text. The text is displayed in a field in either single or multi-line format. It is important to note that an editor may be invoked to type or edit large text instead of using a text item. Dear learners, let us now learn how to create a text item in the form. In the Object Navigator, click the plus icon beside the desired block node. The Form Builder expands the block node and displays its subnodes. Click the Items node. Click the plus button in the toolbar. A new item with a default name is inserted under the Items node. Double-click the object icon next to the newly created item to invoke the property palette. Set the desired properties. List of values. The list of values, more commonly called LOVs, is a list of large number of options in order to select one of them as shown. The LOV also provides multi-column selection list. Dear learners, let us now learn how to create an LOV in the form. There are two procedures. These are using Wizard, using Object Navigator. Let us learn each. Using Wizard. In the Object Navigator, click the LOV node. Click the plus button in the toolbar. In the new LOV dialog, choose Use the LOV Wizard. Let us now learn to create an LOV manually. Create record group in Object Navigator. Create LOV by pressing plus button. Double-click the object icon beside the new LOV to invoke the property palette. Set the desired properties. Master Detail Form. Dear learners, recall the concept of Master Detail block discussed earlier. The Oracle Form Builder manages the data in Master Detail block. Just like Master Detail block, the Oracle Form Builder provides facility to create master detail forms. It always has one-to-many association from master towards detail. Consider the master table student and detail table course registration. The table student has one-to-many association with table course registration, as one student may register many courses. Joining condition of master detail relationship forms. Dear learners, the master detail relationship is established by joining the primary key of master table with the foreign key of the detail table. Creation of master detail form. Dear learners, let us now learn creating a master detail form. Create the master data block on the student table through Wizard. Create a detail data block based on the course table. Create a join condition based on the primary key of master table and the foreign key of the detail table. In the layout wizard, align the data block as desired. Dear learners, The master detail form created is shown as
Dear learners, so far we learned to generate queries using SQL and design sophisticated forms using Oracle Form Builder. Now it is time to learn reports generation. This unit focuses on report layout consideration and generating reports using Oracle Report Builder. The objectives of the unit are to explain report design considerations, various components of Oracle Report Builder, and designing of reports using Oracle Report Builder. Dear learners, as you know that data is always captured in databases to provide required outputs. There are several means of outputs such as queries, graphical outputs, and printed reports. The report is one of the important means of output as shown. Characteristics of reports. Some characteristics of a report are: it shows summarized picture of a project, it provides useful information and details, it is used by managers for decision making. Reports classifications. Dear learners, there are two classifications of reports: summarized versus detailed. The summary report is a report which contains summarized information. The detailed report is a report which contains detailed information. External versus internal. The external report is a report which is used outside the organization. The internal report is a report which is used inside the organization only. Layout considerations. There are several report layout considerations which are recommended to keep in mind while designing reports. These are: report title. The report title must clearly identify the purpose of the report. Column labels. The columns must be properly labeled. Maximum readability. The report must be designed in such a manner that it is easy to read and interpret. Space management. The space of the report shall be managed properly. Order of items. The data items presented in the report shall be organized in a logical sequence. Efficiency. The report being designed must be related to the matter, thus unnecessary data shall be avoided. Type and style. The report must be designed according to its type and style needed. Dear learners, the Oracle Reports Builder is a built-in powerful report designing tool used to build sophisticated reports. Oracle Report Models. Dear learners, there are two models that determine the look and feel of a report. These are: data model. It retrieves the data used in a report from database. Layout model. It defines the layout and style of a report. Oracle Report Styles. Dear learners, the Oracle Report Builder provides many report styles that are tabular, group left, form left, group above, mailing label, matrix, form letter, and matrix with group. Tabular style displays records in rows with column headings at the top of each column. It is the default style as shown. Group left style is used to group the data and is displayed in the left side on the report page as shown. Form-like style displays data in the form format as shown. Group above style is used to group the data and is displayed at the top of the report page as shown. Mailing label style displays records arranged in multiple columns on the page as shown. Metric style has headings for each row and column as shown. Form letter style wraps the text on word breaks as shown. Matrix with group style is like a matrix style but in the group format as shown. Oracle Report Builder Components. Dear learners, the Oracle Report Builder is a report package designed by Oracle Corporation which provides complete environment for report designing. The Report Builder provides these commonly used components: Object Navigator, Live Preview, Data Model, Layout Model, PL SQL Editor. Let us discuss each in more detail. Object Navigator. The Object Navigator provides a hierarchical display of the objects in all open modules as shown. The main objects in the hierarchy are Report. It offers facility to either run an existing report or build a new report. Template. It provides facilities to design new templates for the report. External SQL query. It provides facility to accept an external query. PL SQL library. It offers platform for residing of different procedures, functions, alerts messages, and more. Live preview. The live preview is shown as: it shows preview of the designed reports. Primarily, its view guides for modification of the reports designed. Data model. The data model provides the structural representation of data in the report, meaning that how data will be displayed. For example, in a payroll report, it is required that display of records is department-wise as shown. Layout model. The layout model provides layout facilities like designing of buttons, text items, display items, labels, picture items, and many more. PL SQL Editor. The PL SQL Editor provides an interface for editing of PL SQL commands as shown. Basic report design. Dear learners, after knowing the concept of report, Oracle Report Builder and its components, let us learn how to design and develop report using Oracle Report Builder. Run the Report Builder from Start Up menu as shown. After loading the Report Builder, the screen of Oracle Report Builder appears as shown. Next, welcome message appears as shown. Next screen appears with 8 different report styles as shown. Select the desired option. Next, Query Wizard appears with 2 options as shown. Next, the database connectivity screen appears, asking for valid username and password as shown. Next, the SQL statement screen appears, in order to provide SQL statement as shown. Next, the column selection screen appears, for columns selection to be displayed in the report as shown. Next, the template screen appears, for template selection as shown. Next, congratulations screen appears as shown. Dear learners, after learning developing a report, let us learn how to run a report. It could be run from Object Navigator, Layout Editor as shown. The report developed is shown.